which is up to change because of the complications, potential complications with the one that we saw. Okay, cool.
So the payload is going to be a 3U cube set like we have done in the past. It will be email for everything but the plug because like we need to move it straight to away. Okay, so we're thinking of using patchy or stronger filament that will provide the plug.
All right, so the first one of the experiments that we have the ideas we have, and we've talked in depth with one of these professors. We talked to Professor Cheel about his idea for slugs in space. The scientific goal would be to create a space of the payload as an enclosure for the sea slugs and use the camera system to observe how they are impacted under extreme V forces and momentary zero gravity. Professor Cheel does research with this type of slug called Aplysia california. They're sea slugs. And he's very excited. He's willing to assist in testing. He's willing to contribute his resources to make this experiment potentially happen. The slug enclosure will contain a small air pump system to ensure that the water is aerated and the slugs have enough oxygen. A cooling mechanism. It can be, we threw around the idea of a Peltier cooler or just ice or something cold around the outside, and then to maintain a low livable temperature. This is an extremely complicated experiment. And it would require a lot of testing on the ground, but at the same time, if you can pull off a biological experiment where you keep anything alive throughout a rocket flight like this, it is very impressive. And Professor Cheel also said that we could potentially make this HCl.
So the materials that we use for this, we have the micro submersible pump camera. We're looking at one camera I did last year, and that was one camera to put like this. Like 128 gigabytes because if we're going to record for the close out, that's just like at 10 yet. LED strips and cameras and batteries. An LED strip, so you've got 60, and we got some batteries, and then we haven't tried exactly which batteries we're going to use, but we do know that it will be enough space to fit it and weight. For installation, we're looking at aerogel installation sheets because they're lightweight. And they do have very good installation. You can get them pretty cheap right now. And you can cut them and it'll be pretty easy to do. And we need to use, but if you think we're thinking of ice or PCM, which is like, they're like melt at lower temperatures, but mostly ice is what we have right now. And then ice there would be enough space for ice, some calculations then. There'll be enough ice that we could fit. And then the enclosure to make sure that it doesn't leak. We have acrylic around the fluid box and salt water. And then like a plastic lining for the ice, making the installation right.
So pros and cons. Pros, it could be potentially publishable in a paper. The professor is very excited about this idea and is willing to give his time and potentially money to make the experiment successful. If the experiment is a failure, we still will get a lot of great points through the documentation of our procedures, our processes, our testing, and how we went about approaching putting a living organism into a rocket. It could be a really cool experiment. Upon success, would be very impressive, and it's a good challenge to try to have us think outside of the box. Difficulties, obviously, as with anything living, is keeping them alive, maintaining a livable temperature, oxygen flow, ensuring they can survive the landing impact. We would need a lot of batteries to power the camera system, the air pump, the cooling system, everything that we decide on. It's a very complex experiment, but it could be extremely cool if it was.
So another idea we had was ionic batteries. Ionic batteries have ionic liquids inside, which is basically salts at room temperature. And that makes them really good for withstanding temperature changes, like really high temperatures that other batteries can. So we test how they perform in rocket flight and how like the voltage changes, the operations and the voltage and all of that. There were a couple of professors that we were working with. One of them produces ionic liquid batteries in the MIT department. So he would probably be willing to give us some, help us out with it, and to be able to do stuff with it.
Right. So some of the materials we would need, a lot of electronics involved in this one, so we would need analog to digital converter, microcontroller, SD card, real-time clock. We would need for the batteries, the custom ionic liquid battery pack. This is also has a lot of restrictions on it, because I know lithium ion batteries are restricted on the rocket, so we would have to like communicate with officials and see how we can maintain and stay inside the rules for this one. But it would be like beneficial if the professor who makes the batteries can help us with that and like work to set up the electronics for that.
Yeah, so some code, very applicable, it's big it's like the ionic battery liquid and the battery. Because of the nature of space flight. Also a professor who could help us with it, and they would not be impacted with heat, and we could potentially use them on future rockets. Cons, it could be pretty complex with the electrical system. I know we have some trouble in the past with electronic systems of payloads. And we still need to clarify if ionic batteries are allowed, because they do say ask for specific batteries, we need to have clarification about. And then it might get disconnected.
All right, so our next experiment idea was impact resistance. We talked with Professor Winneck, who has studied phenomenal dampening properties. The experiment goal for this would be to test the usefulness of polyisobutene ether as an energy dampener for rocket flight. This could be implemented with an accelerometer to measure dampening effects that the polymer has on vibrations and impact versus an accelerometer with no damping.
So what we need inside would be two accelerometers. One is like a go to see what it is. And the second one inside encased in the polymer to measure how much the damping does. And then to store that, we need like a controller with an SD card and new batteries power over that. This support. Yeah, we got Betsy.
Pros and cons for this idea. The pros, it's the simplest of the experiment ideas we've come up with. We would wire one with impact resistance and one without, and measure the differences during rocket flight. It's applicable to real world rocketry, as impact resistance is very important in materials that are used in actual rockets, and it could serve as a method for evaluating safety and durability of equipment used in potential rocket packaging, used in collision of rockets with either the ground or something else. Cons, somewhat complex electronics, resulting in potential difficulty collecting data. It's a little bit costly because we talked with Benek, but there's not really too much of a connection for us to get the materials we need. Testing will be just likely destructive if we apply impact and the impact resistance fails and things break. So if we wanted to do extended testing, we would be limited in that in the materials we could use. So limited repeatability.
So our next experiment would be pretty similar to the slug that the flies. The professor here is doing research on healthcare, which is like the wings of flies, except evolutionary, this specific fly cover them. So we might look into how they react in flight with their healthcare and how they change in flight. Flies are a lot more temperature resistant than slugs, so they could survive the heat. And we would have like a camera system and a liquid.
So some materials that we would use: electronics, a camera with a micro SD, LED strip, batteries. The enclosure would probably be made out of some acrylic. These flies don't really need food. The oxygen in the container would probably be enough, so they wouldn't really need a pump. They would just need to survive. Flies are very small, so they can withstand a lot of force. So, but at the same time, they're flies and they do not have a very long lifespan. So
Yeah, so some of the pros I think this mission to flight effect and the low mass, stability is great. However, they might die and full on, and it might be a little, it might be kind of complexity of the bit. And then it'll be, like you said, it's an electronic system, so it's also cameras with.
Here's our. So, so color key, green obviously meets the requirements, yellow clarification will be needed, and red does not meet the requirements. All of our experiment ideas meet the requirement for the payload to not contain any live vertebrate animals. None of these animals that we would potentially use would be vertebrates. Payload shall not make use of any prohibited batteries, lithium polymer batteries, lithium ion batteries. The ionic liquid battery experiment needs some clarification on that. Payload should conduct a relevant experiment. All of these seem pretty relevant to advances in science and rocket. Payload should exhibit a CubeSat shape of 3U. Yep, that checks out for all of the experiments. And payload should not weigh more than 8 pounds. We believe that we can keep all of these experiments within the 8-pound limit that we did set.
Okay, so it shows.
Design. Slugs in space. I'm sure a lot of you are like, oh boy, this is gonna be interesting. So here's our risk matrix for slugs in space.
Yeah, so payload structure stuff, it would be pretty bad for payload, but it's a little unlikely, especially if some testing. Make sure if cooling system and oxygen would need a lot of testing. Shield would do a lot of testing with us to make sure, but it would be very tough to feature and it would be catastrophic. They might not, it's pretty fast on Instagram. The stuff next to that, and then what you really don't want in the we really pick up that.
Yep. If the team is vehemently against us doing slugs, we are open to change this idea, but we are welcoming feedback and questions of all.
Question.
We'll start with whatever slide number, earlier slide number of this one. 5, is it 5? And then before 5.
Or just the dimensions are given in the requirements I've mentioned, that's on here somewhere.
So we have to have all of our dimensions.
No. Well, specifically because the IREC requirement is met, but this should be in that, that's what you're ultimately saying.
I can just 3.93 isn't the exact location.
Yes. If you have any sort of water containing, you look up how the film react to water.
That's you.
Yeah.
But waterproofing 3D prints us.
Absolutely. Nitpick that you mentioned the experiment that you're choosing before you mentioned that you chose it on the slide. Like the third bullet point.
No, they're just saying even if we're waiting this slot experiment. I see it. My comment was, so you mentioned temperature, you mentioned oxygen, great, slugs need both of those. Water and slugs also have a pressure range that they live in. Yeah, when we are at 30,000 feet, we are not at the same pressure as ground level. Watertight does not mean air, waterproof does not mean airtight. So just because it doesn't leak doesn't mean that the pressure won't equalize. That is bad because then your water will start evaporating and your slugs will explode.
So are you saying we should incorporate some kind of pressure system?
No, it shouldn't be a pressure relief, it needs to be airtight.
Okay.
To avoid.
Yes.
This is what I mentioned earlier about using a water bottle as opposed to making something ourselves with that was that we know will be
Yeah.
and again, comments on the feasibility of actually being able to make an airtight packaging of any kind. I'm the case on that.
I'm acting as a scribe, so that everyone who just asked a question and all of those answers just be repeated. I'm really sorry about this.
You first.
Oh, okay, so, I said on this slide, it needs to be air. Yeah, so pressure considerations, the pressure. Of like water evaporating.
And then, Pechi and water would not be a good combination.
Is that slide 5?
It's like 4. It is four.
The slide number is obscured on this slide, by the way. It's in the It's. Yeah, that's.
Yeah.
That's.
That's the
Oh, yeah, what did you say? I was saying make versus find, but look, if we were doing this, investigate actually buying something instead of making it like a water bottle. Example. That would be airtight. By the guy.
I guess. So. I guess it kind of depends on what exact system you're using. For temperature management. It's either where is all of the heat ending or how are you controlling the temperature? Because you mentioned like ice, right? You can't really control what your temperature is with that very easily. So like when you're just sitting, when you first enter everything, if you're cooling your slug down immediately to like near freezing, that could be a problem. And you mentioned coaching modules as well. Where are you dumping all of that excess?
I'm looking at this design, we have this up here, and then. For the ice, they can survive like 0 to 30 Celsius, so they have a pretty wide temperature.
Okay. Make sure. I guess also how long is it in the last?
Yeah.
In the sun, when it's already 100 degrees out. Ice will melt pretty quick, and it's theoretically on the back of the bike. And theoretically, yeah, I think the requirements of that, so. You might need to some of the active cooling system, in which case you're at plus and also where does the heat end up?
In addition to that, we could be in the holding cell overnight, in which case that would be about 24.
Well, we don't. That's all.
But I assume everybody else in the team would rather the bracket be in the holding cell.
That is pretty much.
Requirements about holding cells.
But that's just for. No, have them all.
Yeah.
Yeah,
You can't not have a slug.
well, you can, but you can't back.
Would anything experiment like I data uploading Google?
So like. In RF. That's very, none of the is very. No, it would be, I don't think.
Their entire bread, I got very big.
Like if I was not wrong, but isn't there also a concern that oxygen is a lot less?
Yeah, where you're getting the oxygen.
Yeah,
So they don't use that very much oxygen, I believe, so we were just gonna have an air pocket. And then the bubble, the air pocket.
So when you say not much oxygen, what does not much mean? Because there is like no oxygen essentially.
Exactly.
There's
There's no like concrete data, it's exactly how much oxygen these things need. But there's slugs, so it can be assumed that they can survive several hours on very minimal.
But sea slugs doesn't mean they're minimal oxygen, they're not absorbing oxygen through the air, they're absorbing it through the water, the water's not oxygen. They're gonna die.
yeah, that's one of the things, especially if we're talking about very long launch pad. That water is gonna end up like building up a lot of carbon dioxide. And that's just gonna cause a lot. Also, you have to consider pH levels of the water as well. I mean, actually, that's.
Yeah.
Pure water does what I said.
Also, and do they need salt water? Is that also something they should here?
And then also, yeah, like the one playground said, it doesn't matter if you have a ton of
Well, like for
oxygen.
Daniel as well.
No, we're good.
Okay.
Yeah, it doesn't matter, like, yeah, if you have oxygen, if you're filling the water with carbon dioxide and not taking anything out.
So you need to have something pulling stuff out of the energy pump. So that would have to like be a quote unquote water purifier in that sense. And that would be. As
Yes, so I was just gonna add, I was gonna answer this later, but
just given that everybody's bringing these things up, how much like engineering support can this professor provide? Like, are they like, would they be like working with us like on the design of this whole thing, or are they just like?
On the design of it, but they would be so on the testing, so like testing, how much oxygen do these things actually need? How much impact force can they handle? And just stuff like that. So we would be charged with actually designing the payload containment unit. And they would be, and I'm sure they might provide some funding for like purchasing, cooling and air pumps potentially. So, yes. So you can imagine, however, you drive, since I've been a while without.
Okay. Well, okay, now, my thing was, if you are filling, if they are filling the water with their own food, it's,
I don't think that in a 24-hour period that was the major.
okay. That was
Oh, yeah.
just-
Valid company. It's practiced on this spot.
As you have this drawn out, right? If, and then obviously this, this sort of, but like if a pump is trying to use an air pocket on top of the bucket, like moves them all off a vertical, this pump is going to ingest water.
Yes. It's not, the flight is, I think it drives a little bit.
I'm at, well, but they call the pump break if it gets.
That sounds like a detail.
Yeah.
So also, we won't have to seal the slug in, right? So at what point do we seal it in there and then, like how long is it going to be? Like, is it going to be more than just the 24 hours we're expecting, or could sealing in there last longer than we expect?
We're. For a lot of big concerns we also talked about was transporting these things. These things are transported mostly in styrofoam boxes with an ice pack. And during transport, they do undergo some amount of stress in that they're kind of thrown around. So they're not extremely sensitive, but at the same time, we're applying an insane amount of force. And then one of the different factors I can just right here, but they don't die if you throw. So they're a little more relieved. Under 8 pounds for the whole thing. 8 pounds over.
Okay, I'm assuming that that's without taking into consideration the fact that there needs to be some ways like low control the pH and something like that, the rest is that, right? Okay, so then we can possibly assume that it might be a little bit more than that, it's 12, the additional equipment inside of it necessary, right?
We're hoping not, if you manage to make the outcome of the payload out of something lighter, like the acrylic, for stronger filament, hopefully the lightweighting of the frame of the payload would like counteract the additional to maintain the skills they fiberglass.
You could find like waterproof products and stuff.
Yeah, we're thinking of no,
Like the details.
Yeah, yeah.
Elements,
yeah. Oh, it's only like a couple. They could be like one or two, then. Okay, good. Tank could be good.
Because I was like, water, there.
No, we're still waiting with the. So. It's,
Is 8 pounds the maximum we're allowed to have?
It's that.
but.
I wouldn't be too concerned about these being overweight in general, just because so much of the payload is usually over designed to add weight. That I'm weight would not be a concern of mine for any of these payloads, just for future reference, just having worked on that before. They can be made lighter fairly easily.
Well.
Are you planning on wondering do that piece of this? Because if bringing that as a cylinder and a plasma shape, would there be a difference in acceleration, like you have two plates like this? Or enter whatever thing, acceleration like axially versus radial? Those or you just taking one?
How much do we care? This is not a design dictate.
They might think that they might change their mind, so it still matters. Okay.
Or do you, yeah, I think. It depends if we wanna add that complexity to it, we could potentially do 2 batteries, if it is within the rules and like within. Our means and measure both axial and radial. Or if we wanted to simplify it, or just do the axial or the radial. But yeah, potentially if it's within our. What's the
Scope.
yeah, scope, I guess.
Talk with the professor about if they know and. Or if they think that it would make a difference, it would be with having to also all make of these batteries actually, and that also matters. And we don't really need to go over that now, just remember that. In the past. Yeah, but not a complaint. Okay, so. Why do you like this? Is just. This may lead to follow-up questions, but this is my question right now. You're measuring resistance and voltage. Why do you need an RTC?
So that'll be the see when exactly it's like that's not the injector.
Your
And-
microcontroller, if it's like any functional computer will have a clock on it.
Yeah, I don't care about time. Yeah. Doesn't mean a difference. And yeah, the other question, that is off that is, why do you need a gamma micro, or what is ADC?
We're looking at one specific one that just, but
Okay.
could go.
Just DC.
Yeah.
Also, with. Is that onboard ADCs are probably good enough, but I think you might need smaller. It's not like if you need the battery only has like. But if you're like 7 if you're still tempting something. Anyway, and the other question that I had was, because you're doing time from launch. You are going to need to detect launch.
Yeah.
How are you going to detect launch?
That's kind of why I see.
Okay, but see, the thing is, you don't know when launch is, because none of the other things that are detecting launch have us to see.
YouTube video.
Yeah.
If you get a microcontroller that has an accelerometer on, you could just,
Yes,
Yeah.
or you can get an external reference.
yeah. On this list of electronics, you have it in the picture, but you don't mention the fact that this stuff has its own independent separate from the total battery. Why?
No, why does it count?
It does, I'm saying it's in their picture.
Yeah, no, why?
Why, do you want to power off the experimental batteries?
It wasn't explained, so I'm gonna.
So you. Modules, accessories off of the battery that we're using from our experiment. So that is why there's separate batteries from the custom amount of batteries pack that we are running the experiment. Cool, good explanation. Cool, awesome. Any next slides and questions? What's 11? 11, procedural.
I really like this.
I don't see.
This is, you know, I wrote banger. Yeah, you should look into this one more.
Any other questions?
You're all about it.
It was keeping it simple.
You know, like what kind of vibrations this thing is basing, like how fast or frequently. It might be more of a detailed question. You need to, if you choose this, what you're going to do, more detailed about you need to know what frequencies you're actually able to see. So you can use a accelerometer that has a fast enough sample. If you're going to be seeing arbitrarily say 1 kilohertz acceleration, you have a 500 hertz accelerometer, you're getting real good data.
Yeah.
And that might also depend on the geometry of your support structure. That was considered.
That is a good thing to consider to see the accelerator to so much data. Very. Okay, any other questions?
13, but.
Sure.
Was.
So they all have started, so we're. Whatever supports you think exactly saying you're listening really depends right now. Interesting. Or is it going to be enough, would it make more sense? Or something else, everything, is if you're trying to measure the performance of something that's slightly less, but your support is also within a close enough range of stiffnesses that it could affect those results. That's kind of a problem. Yeah. So I kind of know how big the supports are, right? If you're only spinning like a quarter and it's probably not gonna matter.
Definitely looking to different variables. The voltage, like, so that the vibration of the poles is not also being recorded in addition to the vibration of the material.
You can consider mounting the material directly to the panel plane if possible, because actually. Like on top of the, like just anywhere on the unit structure itself. Whatever works, that's the design. Yeah, you mentioned.
Yeah, so my thing is not really what it's just, your limited repeatability as a result of founding variables, what does that mean?
So basically, like, if we wanted to test impact resistance on the ground, we need like how it would be impact size, like forces get like be what we could kind of expect when it's launched and make sure that nothing's gonna fall out of place and that we're actually getting data that we want by testing on the ground, and we break some of the material that we're using. Or like, we would need a lot of material to test different variables like temperature, like frequency of vibrations. And just, we don't know if we're gonna be able to get all that material, do all those different tests to account for the amount of variables.
Okay, you would need a lot of floods to do that, you need a lot of a lot of batteries, but that's.
Like the.
Yeah, so that shouldn't be a con then, it applies to all of them.
Good. One thing I've been curious about is like this material, if we have to manufacture it into some shape, right? And we've never worked with that material before, and if it's really expensive, how much money are we willing to spend on learning how to actually turn it into what we want to make it?
So they have a lab on campus studying participants that a PhD student working in the Galen who does it. And he said he'd be able to make a bunch of different form factors. It's pretty easy for them to do.
Okay.
Why is there grace? We can end of the straight badass. What like we normally we use like an 80 30 or something, but it's stuff around there. I suspect that will be a resolution of either spatial or temporal. So it's probably going to be a lot of consideration goes into what kind of cameras you use and what kind of data the overhead needs. What data you're gonna end up with that's back. If you end up needing just arbitrarily like 4 days, like says like that's times the data of any 60, but it's really the same impressions. No. Cameras probably that will be able to pay really step back. That's camera exists.
There probably are cameras that can fit within the confines of the payload that can record fast enough. That's based on intuition, but like they're probably gonna be a lot bigger than you picture, so you're gonna have more camera for less fly space as opposed to. I mean, that camera would even cover, as you have it on, really get the full field of view, so.
Same considerations with these slugs, pressure, like they really fit. Yeah, and I know you said something about temperature and how they're resistant or whatever. Yeah, okay, so the difference between slugs and this is, the slugs are in water. Water retains decently well. It's fine. Here, especially if it's not airtight, it's going to be equalizing with the outside. It is also extremely cold at 30,000 feet. So yeah.
I mean, even air will be cold for very long.
Up there for like.
I
did it.
know, but okay, but yeah, you're only at 30,000 for a little bit, but even above a few thousand feet, it's still pretty cold.
I think though, if you consider all the heat energy that it was like stoked up.
There's fine.
There's a lot of certain.
It's there, it's not that stupid. Okay. This,
That's probably fine. No, but like, I mean, it is in the negative area. Above like 2,000 on the ground. I think it's pretty good rain.
It wouldn't be terribly difficult to deal with. You just need to
Yeah,
actually.
you would have to deal with it.
So, they said there would be a camera system to see the different to see how they react to different condition of light. Then I believe it will be inside rocket. Shouldn't the condition of light be controlled by Earth? Then
Really. Absolute pitch darkness, so we would be small. Something like that to provide light so that the parents can have the given place. And what we're really looking for is even like, how do the flies stick to the walls? Do they jump wings if the rocket is like taking off or something, just behavioral. Data against aerospace. During flight, during potential zero gravity, or temporary zero gravity. Yeah. Any other questions on this slide? Next slide, the questions.
Doesn't mention on that, the air type again.
Yeah. Absolutely.
I'm saying about the compliance matrix.
Yes.
Oh, no, not the climate, in my CEO, that's me.
Okay, hold on.
More than four requirements for the payload. It's all.
Yeah,
Fine, sorry.
we were saying Julian's presentation thing, he said, I mean, the necessary things like when he talks about very and just like not including lead and that. Thing on the slide.
Like, or the actually. I don't know.
I would feel so. Well, I would say that these are the relevant requirements. The other stuff is, I mean, payloads requirements are also very lax and that this is. It's hard to fail them.
Yeah.
If it's staying in the lockdown. Yeah. You should definitely have at least 2 5x5s on. And I think number one is that the cooling system should definitely be a 5x5 because I'd say that's very likely to screw that up. And yeah, I also expect water type to be higher. So like in general, I would raise the likelihoods about here a lot. Not a lot, but like at least some of these people up by one, for how likely they are, because this is a very risky experiment and limit that I would expect to see very risky numbers and ongoing it. You should also have a column of the actual multiplication because some people already look at labs and see. One divided by.
I thought it was like on slide like, what was the reason for it to be like slugs? Was there a technical reason or just like it better? Regardless of what it is, why you chose it is kind of important.
Yeah, absolutely. I think it was mostly because we had the communication with the professor and it's like we met with him twice as compared to something else, like a lot of programs we didn't get a response. And then some programs we met with them once and they, like I know, Del Florio told her to contact Jessica Fox and she never got back to us. So just, I feel like we were running into dead end with the other professors. But Professor Jill seemed very interested. He also seemed like he had like the resources to help us like actually run experiments on the ground. And was like willing to work with us and do that with us. So maybe just that communication. Also, it is cool and like it's a great challenge. But if we're just literally against it, you're up to it. So I would have to be some it's hopefully we can keep those speculations. Put it on there. Yeah, yeah.
Oh, my comment, that I left, I'm gonna ask it in person. What does test mean?
Guys, for the fitting, we're gonna make sure the shoes and like put some force against it to make sure it's actually secure. And then we'll.
Okay, it's easy to go, it's not this way. So extensively test the cooling system, just like. Put it, once we have the box or the payload that's where the subs are gonna go, just see how long the ice could last before it melts. What the actual temperature inside of the box gets to at various temperatures, so like when it's room temperature, what's the temperature inside the box? When we're out in the heat, we can like put it in an oven or something and see how the inside of the box temperature changes. So that would be testing the cooling system, testing the pump system, seeing what are carbon dioxide levels inside the pump, when we have slugs in the box, in water with the pump system running. How long will they survive with the pump system running and like nothing else going in or out, no release of carbon dioxide or anything like that. Last long enough to unarmed enough, see what happens during that rotation to ensure the pump doesn't get backlogged with water or plugged into the way, and that it'll still work when the rocket is like moving about and undergoing different pressures and forces for us to have a test.
Yeah. So my point was just that your mitigation gene is just tests. It's like, okay, I made it and like it sat there for a minute. I've tested it, right? So like I was like say what test you can also like feel a lot more involved what you're gonna do if your test. That this is a risk and our test revealed that it's going to happen. What do we do?
In number 5, you say an insulation act is pushing material. What materials have you looked into that would be both insulator and pushing?
So we can see it
It will shatter on impact.
I was just saying,
Yeah,
I think it's pretty critical. That's also why.
Aerogel is not really a gel. It's not like.
It's glass. Aerogel is very fragile.
Mechanically, pretty flat.
Well, I do have aerogel. Yeah, really, I mean, it's all like experiences.
Yeah, for the ones we can probably obtain error, they're very good. So either have 2 different materials to do that or different.
Most the aerogel really great. But yeah, lands.
If you or if you go for it.
Yeah.
You could put landing legs on the rocket in addition. the professor's willing to just support us. In what ways?
Yeah, he mentioned being able to run a pocket with the person in the building too. And then you mentioned recently lab that tests the key capabilities.
So they'll cover like the slugs and stuff, but this will also cover like, yeah.
He would cover, he's looking at cameras that he, okay, buy him from certain sets and stuff.
Oh.
That's it. Thank you guys.
There too. I'm taking that shit. I just have another plug to use to. Use the form for questions. So I just sent it to level one, sorry, it's for those of you who might have walked in late, there's a form to ask questions that if you don't want to disrupt. And like don't know, clarifying questions, about general rocketry things, you can ask it there. Team members like Chris and Groove are sitting on that spreadsheet right now, and I those questions. And then generally the way we are doing this is we're gonna go through everything else in the slideshow. And then we're gonna ask questions. If you have with technical questions, write them down, write down the slide number. The slide number is in the bottom corner of most of the slides. Write on the slide number, and then we'll go through by slide number. Any clarifying questions can be asked during, so like if you're like, what is that in that sketch over there? But other than that, any technical questions should be kept for the second round. Eric, what's your time?
Okay, so, we're gonna start with the collapse and recovery schemes of all the rockets. And then we'll go into the different design options that, Robbie and I have created, then we'll discuss the design. Before we do that, first thing, D-Type came out, not officially, but, these are some of the rules that they're thinking about changing. So we have adjusted our design to fit these. The main one that, we're gonna be focusing on is 1.5.1-1. This meant that, the stability off the rod had to be above 2.0 bottom calipers, so that, big change from last year. And you'll see that in the rocket designs. The first recovery, so, okay, once. So this is the general, for the, rocket launch, and then lift off, motor burnout can happen after about 6 seconds at 8,000 feet. Apogee, obviously at 30,000, and oh, yes, motor that we're using this year is an 03400, by Cerrone. And then, so 1 second. Okay. 1 second after apogee, durable deploy, slowly fall down until 1,500 feet when the main deploys. Then, after about 5.5, 6 minutes, we'll land on the ground. So this is design one for the recovery scheme. This one is pretty similar to ones we've used in the past. Just that we are using floating charge wells instead of the charge wells inside the bulkhead, so that we're not doing a loaded gun design, which was a requirement according to the so yeah, so during integration, these charge wells can be moved out of the way so that they're not like you're not screwing in something that has black powder. And then if it goes off, all fluff. So the one thing that is a little bit different this year is that the nose cone coupler will go with the lower body instead of going the nose cone. That's an important design change. And then the nose cone is yes. Oh yes, the bulkhead above, there's gonna be a bulkhead above the payload that will also go with the lower body. And that's where the parachute bond will be attached on that bulkhead above the payload. Here's another diagram of it, kind of like in action. And then you can see the packing diagram on the on your right. Yeah. So some pros and cons for this one. Projection charges can be kept out of the nose cone for integration. And then floating charges have allowed for more complete combustion, so it might be a little more reliable when it gets up to half of the end. There won't be as much issue of like, will the nose cone separate or not. We got some more free space, and then large space for eBay means that there's going to be more
hard blast around it. With radio and parent, so it should be easier for avionics to GPS tracking stuff. But the packing scheme is a little bit more complex than the other design and it's the flaws.
Alright, and then the second recovery design looks a little bit different. It's like kind of flipped. So in this design, the eBay is between two bulkheads, the eBay bulkhead and the we'll call it similar protection bulkhead, but it'll like be attached there, so the threaded rods is to attach the like eBay through one bulkhead, because obviously we can't bolt the eBay bulkhead if it's like in a coupler that's trying to separate from a nose cone. That's what the threaded rods are there for. And then the charges are on top of that bulkhead, so the idea is that we're integrating, it's not within any like phase, the charges are just at the top, so we don't lower your hand off.
For clarification.
Yeah.
There are radio voltage to be lower eBay bulkhead at top level.
Yes.
Sorry.
And so yeah, same thing, couple goes with the rest of the lower body. And the one thing that is my bad not illustrated in this diagram is that in order to attach the recovery lines, the nose cone tip would actually have a threaded rod and a small bulkhead on it, and then so if you want to like obviously then we can that cool down. And so it would be like nose cone tip, small threaded rod, eBay, and then the recovery lines would attach to that eBay, but not the eBay, sorry, bulkhead. But the bulkhead would really just be there to hold the nose cone on. So yeah, this is the scheme for that. The packing for this looks a little bit different because it's a slightly like wider space. And so the things are to pack horizontally, you don't need to work the D bag, so yeah. Some pros of this design is that the junction charges are never in a confined space. And a lighter bulkhead does allow for more additional packing scheme as opposed to the other one. One of the bigger cons for this is that there is less vertical space for the eBay, which constrains the antenna length that we can use, so we have to work around that. The nose cone needs to be retained in a way that would make integration a little messed up. It would just be complex. And then also, the big one with this is these coupler would have to be fiberglass, since the eBay is the nose cone coupler. The nose cone coupler and the nose cone would both have to be fiberglass. Yeah, and then dimensions of recovery ended up being the same for all of the designs. So you can see here, they were gonna make diameter and put it with drag. That's what the numbers I did. So yeah, that's recovery. Redesigns.
So this is first design, 2 ballast rocket. You can see it here, the main thing, this one, there are 2 ballasts because of the new G-type requirement requiring the really high stability off the rod. And the heaviness of some of the composites that we manufacture in-house. I was thinking it would be a good idea to maybe house a ballast up in the nose cone chip, or up in the nose cone, to counter that like stability and make it more stable. That being said, when I simmed all of this, according to the right rules that we put in, I simmed them both at 0, so it could work out if we did that perfectly at max. And then another note, I'll talk about this more in a little bit, but because there isn't anything too crazy in the rocket this year, actually all of our designers are able to do this, but one body tube, there are no couplers in this one. And you know that, so.
I'm just gonna jump in, if people had questions, the questions are not for like technical questions, they're for like. What is eBay and things like that, so you might have access to technical questions, write them down, save them, we'll go through it. This question answered things. You know, please. Okay.
Oh, also, Andrea left a comment. The thing above the bottom ballast, that is the measurements eBay. So here are a couple of the
simulation things. And you guys move from those. This up one. Yeah, so this one will get up to 31,073 feet. Stability up to rod, or open rocket. We give different answers based on what, like the wind conditions are like, so we looked up the wind conditions at Midland, Texas, and that's why there's a range. Yeah, let's see, like we looked up the conditions at Midland, Texas. I'll go over the parameters, we'll go to the next slide. So we'll go through that, but that is why that makes sense. Yeah, so here we go. So here's the simulation parameters. These are for both Robbie and I. The only one that changes is the launch route length because that is dependent on where your top rail button is located. So that's not going to be the same for everything, but everything else should be the same. Red arrows on the left, open rockets on the right. Thing on the bottom for red arrow, then going through. Yeah. So here's the stability graph for its design throughout the flight. Max it out around 4.5 or 4.85 body calipers. Off the rod was the simulation around 2.15. This graph has the velocity, acceleration, and altitude. So an open rocket doesn't sim as high as red arrow, but it gets up to around 27,500. Velocity gets up to around 1,800 feet per second. Here's the Roger actually, this is what we are basing our altitude measurements off of. Except for a second, okay, pretty self-explanatory. Same with these next two, this is just velocity in feet per second. Velocity in Mach, and then Mach acceleration is around 480. So some pros and cons. One of the pros is it has two valve change stability, so that means that we kind of manipulate the stability after all the mass that we take for done manufacturing. Warp is symmetrical, so it'll be a little bit easier to implement after or implement on the boat tail close to creek. Both valves can be integrated with threaded rods, so they're just pretty easy to put in. Payload is bulkhead on top of it, technically with floating charges, because I know the outer frame of payload was a point that we haven't set on yet. Pretty stable compared to the other ones, and then one body tube will make it much easier to manufacture. Some of the cons are it only works with reverse recovery design because of the valves on top and actually, or they only work with reverse recovery design because of the valve. And then this was true for most of them, but my fins are pretty big and they're a little bit thicker to counteract the fin flutter. And then another con is that it's a little more complicated with both ballasts because in theory ballasts you would put at your center of gravity to just lower your apogee, but because I'm kind of manipulating stability too, it's affecting both like stability and apogee, which could be a little more complicated. And then if the nose comes down ballistic, ballast will mean that it will fall from force and thus damage the components. And then because it's one body tube, the rough transfer bulkhead is kind of far down. It might be difficult to integrate because 2 feet is about the length of an arm. So we do lower.
Okay, yeah, this is designed to, it's called one body tube, as right, even though they all have a body tube, but the design is just helpful rather than pulling. So, and this is SRAD, with a little CP with one great. So anyway, this is the open rocket diagram. Yeah, the features. You can see the fin shape, the fin kind of go into straight section of the boat tail, which is not clearly out of the design. Again, one tube, one coupler. It's a pretty short-ish rocket. This is it with recovery design one, but we'll go into the fact that both low boat tail like angle, the better aerodynamics. Compound and nose cone, factor one. Yeah. And usually it's very fun. So here's the flight characteristics. You can read numbers, I think this stuff for a second. Pretty high altitude, again, this is with zero ballast, in this design, if you need a ballast, it would go on with center of gravity. I was like, that's better. And the body diameter changes because, like, very similar to the videos last year, the nose cone would have to be like a bit thicker, so the nose cone was likely to fit on. Functions. This is the overall flight stability graph. It's the like flight overview with altitude, velocity, acceleration. Again, you guys could see the if you don't put that. For zero altitude, like that this is what we go off of because there are more. Velocity in per second, velocity Mach, and accelerations. So, further this is true for all of them, so probably to be honest, there's the one body tube, one coupler, good manufactured mass savings. It is the smallest diameter possible while maintaining a uniform diameter. It should not actually be slightly bigger. That is able to house the CubeSat.
Yeah, keep going.
Okay. Another benefit of this is payload and measurements all would integrate as one thing. So it goes like bulkhead measurements, bulkhead payload, and it all goes into one thing. So just plug in there and it's easy. This design has really high aptitude without a balance, so gives us a lot of room to mess things up if we do the open one, and we'll just add great balance. This is true of the other designs too, for something to note. The thrust strength of the bulkhead on the top of the motor and the bottom of the measurements. EA is to across the motor and take a load of the boat tail. Like I mentioned earlier, there is a low angle boat tail, it's around like 9-10 degrees, which is good for continuous flow. Some cons of this is that the length of the top of the body tube of the thrust strength of the bulkhead, which is hypothetically the like furthest you would have to reach in the rocket is 21.75 feet. That does not exceed the length of an arm, but it's close. So we shouldn't have to like it should order to integrate one thing we have to fly and have it in a neck or whatever to them. It would be a little annoying, but it's not exceeding length of an arm, so that's good. Stability off the rod, depending on where you think it has, is close to the minimum stability, which doesn't give us a lot of wiggle room. And then the pedestrians, we'll talk about a great study later. So see that with that. This is the rocket with the second recovery design implemented. So this is the only design that can work with both recovery designs. It's pretty similar. The fins, I believe, are a little. Yeah. Oh no, that's the discrepancy. I'll check back with that number, but I don't believe there are ones. But I believe that there's just a little bit, but there's a little bit moving around with the fins. Because with the added mass, it's really other stuff. So we just change things around. These are the flight characteristics. You can see a little bit of a lower apogee there. And I think it's slightly lower stability too. And slightly slower. Yeah. It's the stability graph. The overall open rocket, flight scheme. I'm just legal in that for a couple seconds. Altitudes. Velocity. So, the pros and cons of this design, like it's the same rocket design, so they're pretty similar. And it comes with the same pros and cons as recovery design. 2, program design 1. Oh, no, sorry, the same pros as with when we use program design 1 in terms of the rocket. The only con is that it has a lower apogee, so a little bit less wiggle room there. And then of course, all of the specific pros and cons that come with the recovery design. Yes.
So this is our last design. This one is a commercial off the shelf, one body tube design. So the main difference, most of the design is the same as the previous rockets. It's just that these body tubes would be bought off the shelf instead of us making them in-house. So we would buy them from Wildman, and then we would also buy the nose cone plus nose cone tip from Wildman as well. But an important thing to note is we would still make our boat tail in-house. So that's the main difference. And the main thing that this does is we can't get as precise with the body diameter dimensions. So this one would be like, or it's 6.17 inches in diameter opposed to like 5.86. So this one is a little bit bigger. That is represented in the flight characteristics. This one has a much lower altitude than this because that's 30,000 feet. Also not the most stable. Yeah, good. You guys have seen 3D already, so it's taking too long. Stability. So for pros and cons, same pros that come with having one tube, as design 2 said. And then we'll discuss some of the more specific pros with the COTS 2 when we talk about the trade study after the compliance matrix. But some of the cons of the low apogee provide little room for error in manufacturing, especially since we are still manufacturing the boat tail. There really is not a lot of room to play with when it comes to this design. Same thing about it being one body tube applies to this one as well. The rest of the stuff that they said.
Okay. Compliance matrix. So this is the P colors, and you'll see what that is. Like, I can see you guys need to read, so I'm gonna kind of just leave this up and then explain anything that needs to be explained necessary. Design 2 is with recovery design 1, design 2.2 is with recovery design 2. They're like different stuff. Thanks. Yeah. Instructor requirements. The lock requirement is grayed out because none of the designs have couple tubes that are not intended to separate. Because all designs have just one couplings that will be separated. Oh. 5. Yeah. I'll just have to like 5 seconds. Bulk requirements. Design 3 just gets to 3,500, 30,500. Yeah. Those are the drafts. Yeah, again, the new detail rules about 2.0. Stability probably kind of like this is good design. Yeah. One. Oh, I'm recovered. I got it. Okay. This is the good stuff.
Okay, so we looked into whether or not us making our own tube for the IREC rocket specifically was beneficial. So this is just the results. If you want to see the full trade study, it's linked there at the bottom. I'll just go through a rough reasoning for all of them. So for time, COTS or March off the shelf saves us a lot of time because we don't have to spend a bunch of time prepping the manual. And then also there's less sanding to be involved, even though there still is some like parallel perpendicular we got to do. It's not nearly as time intensive as the student research and development tubes. Cost. This trade study is about this year specifically. So because we are planning on doing the same body diameter as last year, we will already have the manuals and we already have leftover fiber and carbon fiber sleeves and stuff like that from last year, so they ended up coming out at around the same pricing. If we use all those materials. Plant performance, probably the most important one, as we saw with the Apogees. Marked off the shelf, leave us significantly less room. It is possible, which is why it got a score, but their research and developed formed a lot better consistently in our simulations. IREC points, although you can score full, or not like full, but you can score well in the design and manufacturing category with mark off the shelf. We saw that there was correlation between students that design their own tubes, design and manufacture their own tubes, was scoring highly. I believe 30 out of the top 40 scoring teams did their own body tubes. And then customizability is because we can choose our own diameter to fit the 3U tube set perfectly, opposed to the commercial level shelf which come in, I believe it's half-inch increments for the diameter, and it doesn't leave up a lot of. That being said, that's why we chose SRI. You can see the score total at the bottom. Oh. My bad. My bad.
So yeah, a bit of design is design 2, which is the SRAD, one body 2 design, with recovery system 1. So just to remind you, that's this design. It's the same thing you saw earlier with this menu, what it looks like. So yeah, this is a more detailed diagram for separation, so you can see the nose cone coupler goes to the lower body tubes, and then the nose cone itself pops off. With the pieces. Again, his flight characteristics, his Mr. Same thing as you saw before. But yeah, and then is the breakdown of the mass allocations for each of the components. Payload is 8 pounds is the worst case scenario, measurements 5 pounds is the worst case scenario, so these are subject to be decreased potentially. And then the rest is like estimates based on the previous years or like the models. That's how much the model weighs. Yeah. Okay.
So here's the risk matrix. First one, fin flutter and divergence. It'd be very bad if this happened, but I calculated max Q and we simulated the fins at the altitude where max Q occurs, and then we are keeping the factor of safety of 1.5. And then the other ones have to do a lot more with the recovery. So I'm not gonna get sure, I guess I can say. We as a team don't know as much as we would like for recovery. So here are some of the like issues that may present. So we're gonna do a bunch of testing with Arlo in order to combat some of the issues. So some of the issues are like the recovery line breaking during the main deployment, because there's actually, if any of you guys remember, there were on the acceleration graphs and then open rocket, there's like huge spike towards the end. That's because when the main parachute deploys, it like yanks on the rocket, and so we're gonna make sure that those don't break. And then some other stuff like the ejection charge is not causing separation, or the floating charge is burning the parachute and or shroud lines is sort of stuff because then anything is down. So yeah.
So these are some more simulations for the design. Again, you guys can read drafts. I hope I was gonna go through these. Some of these you've seen already, like most of them have. Yeah, ability. This is a more in-depth view of the fin shape. Yeah, 0.3 inches thick, full fins. They are half an inch up from the off end of the book down. So yeah. The fins, incredible. Defensive analysis. I'm just showing you where simulating at 9,000 feet because 9,000 to 6,000 feet plus. We simulated with the 2 carbon fiber material optimally been to be simulated, the one that gave us the worst numbers, the worst case scenario. And then this is the analysis, the numbers that you care about on here, I can point on the side, is total velocity here, and then also the derivative velocity, probably really stick with that. The 2.91 knot is the number that you care about there. And looking at those numbers of the maximum velocity that we will hit and the thin flutter velocity, we have a factor of safety of 1.58, which is above the required size. Yeah, and then just going into the radar analysis again. This is the altitude graph, velocity graph derivative knot, acceleration. And then also this is the graph of CN alpha. So this is to do with fins. CN alpha is basically the slope of the graph of well, it's like it's something that's like lift. It's the normal force coefficient, yeah, that versus the angle of attack. So like if you go off like straight, it's like getting back to being like a straight leg. And generally the rule of thumb is you want to see an alpha above 10. So if we're going to mark 1.8-ish, you can see that CN alpha will be above 10 for the entire flight, which is good. That's what we want. Yeah.
So I'll just run through with here the manufacturing rough plans right now. So here are plan materials for everything. Not gonna read them up. And then so for the manufacturing plan, also was pretty similar to what we did last year. We have 3D print mandrel mold for the nose from toe tail and surface cut that layup, and then get it out, cut sand, body tubes. We already have the mandrel, so they don't have to get it. But we do still have to surface prep it, layup, and then same thing, cut sand, cover tube, same thing. And then for the fins, same thing as last year, except when we are putting them onto the fin can, we are going, or I guess when we make the fins and when we CNC mill them, or no, not CNC, when we water jet them, we'll add a little bit to the like geometry of it, for the roots, so that then we can sand them so that they have like ideal geometry for attacking onto the coating. So and then epoxy fillets, vacuum bags layout over that. And yes, so I think that's it for us. Woo!
We're not going back over your focus, but we're gonna do them all.
So here's the conceptual design for the measurement stuff. First, I just wanted to go over how it's being structured. So we have a hardware group that's focusing mainly on the main eBay that we're planning to have as a separate point, and also strain gauge, the sites where strain gauge. And then we also have a team working on the software for our data acquisition devices. Yeah. Okay, so first we're going to go over our main eBay design. So this is our concept of what our eBay is going to look like. It's basically going to be a triangular prism held up by 3 rods connected to the bottom bulkhead. On these surfaces, we can attach different components, so such as the DAQ device. Here we have pictured the LabJack component or LabJack device that we were planning to use, but not going to use anymore. But I'll get to that later. So it allows for flexibility in what we can put and how much we can put on there. As you can see, here are the rough dimensions on there, and so the drawings and a lot of other dimensions. And here are the views of like where each side of the triangular prism will look like. So there's a justification of why one uses triangular prism. As I mentioned before, The large surface area from using three phases allows us to add many components to it. This was designed for something as large as LabJack, which is pretty large compared to other DAT devices. So we could fit a LabJack, we could fit a lot of other components. Another consideration for a triangular prism is that we can utilize the space inside the prism specifically for batteries. I also been told that we might be adding the camera system in the measurement T base, so this would include batteries for that system. Okay, then so now we're going to go over the concepts for the separation point. Basically, what we plan on doing is having strain gauges not only on the main body to below the separation point, but also having some strain gauges above the separation point. So the main problem we have here is how do we get the data from those strain gauges above the separation point if our main eBay is going to be below. So our first idea is utilizing a VGA table. So this was actually inspired by a BPS space video. Basically a VGA table as seen there means it's a large recently sized table that contains a 14-15 wire inside. The reason why the VGA cable is used in this being considered here is because how easy it is to separate. So as you can see in my very nice drawing there, the connection point will go directly with a line directly with the separation point between the stone and the rest of the rocket. So one of the big benefits of using the VGA cable is that we can centralize where all data will be collected, analyzed, and stored. One con though is that it is around 0.2 to 0.3 inches thick, so that might cause some space issues for recovery and also for the avionics. Our second idea was having two isolated systems. So we were considering using the Arduino Nano DA controller, which also acts as a data acquisition system. This contains a plethora or 8 analog inputs and also store up to 16 megabytes, and it's decently small. So obviously the big benefit of this is we won't have to deal with running a wire to the separation point. But it does take up space but it might potentially take up more space in the avionics eBay than just running out cable. So our decision is to use the VGA cable and attempt to run the wire through the separation point. As mentioned, this will prove to be less intrusive to the avionics eBay, allowing them to have more flexible design. And also this allows us to consolidate almost all the components to the measurements eBay. And one thing I know might be concerned is, oh, this is a really big cable. Are you really going to use 14 to 15 wires in that? We do have a solution to that. We use a special kind of strain gauge called a rectangular rosette strain gauge, which I'll get to that in So now let's actually be going over all the time. So our main priority here is the strain gauges that we're attaching to the rocket. So currently, right now, we have these strain gauge modules here. They basically, it's like a pretty cheap solution to it. It's a Wheatstone bridge with already a pre-soldered strain gauge to it. Strain gauge, like this here, that strain gauge. It's a basic linear strain gauge, meaning that it measures deformation in only one direction, one axis. And it's obviously pretty convenient since everything that you need for a strain gauge, like as they call it, is already there. If we use these, there's probably like around 5 to 6 of these throughout the rocket. As mentioned before, one potential that we could use is something called a rectangular rosette strain gauge, picture here. As you can see, it's a lot bigger. It contains more of these grids here. So basically what this allows us is to measure strain in multiple directions. And specifically, rectangular rosette strain gauges are used when you're not sure what direction deformation occurs, which is perfect for finding something like this. One problem though is that since there are 3 grids per sensor, that means you would need 3 Wheatstone bridges per sensor. So that potentially causes space issues. One way we could solve that is by buying some leads, they're called Wheatstone Bridge circuit modules. So they're good for rectangular widgets since you can add a lot of them into one space and they don't take up much space. It's like a small like metal tab. Though the problem is that since it is a more of an industrial grade component, it does require more wire connections compared to the strain gauge module up there. So it just the complexity increases, but if we could use both the rectangular rosettes and the Wheatstone Bridge circuit modules, not only would we get data in more than one direction, but this Wheatstone Bridge circuit module does offer the ability to collect more accurate data. So it's a trade-off with what's achievable and what's better quality. So now to the devices. So for a data acquisition device, we are initially planning on using the lab jack, since we got it for free and it's very convenient. Convenience in the sense that it provided a good UI for coding. It uses a language called Lua, which we have an expert in that. So however, we determined that Lua script doesn't reach the 500 hertz sampling rate that we set in the system requirements review, just because of how its inefficiency in being able to read the data coming into the lab jack and then writing it to the flash on board. So an alternative is using a commercial off-the-shelf microcontroller such as the Arduino Nano mentioned before. These microcontrollers are meant to be used without an external computer. So the coding that used to that is optimized to achieve the 500 hertz sampling rate. One thing to consider with an external microcontroller is the storage capabilities. We've been told not to use external SD cards, only soldered SD cards. So luckily, since the Arduino Nano does contain 16 megabytes, it should have enough storage for around 5 to 6 strain gauges to last the whole play. So another device that we want to add is an accelerometer. And this is primarily used for trigger the system to start collecting and storing data specifically. One of the things that we determined in system requirements review is that the worst case scenario is that the rocket might be on the launch pad for a maximum of 14 hours. So we want to be able to start. We don't want to be collecting data for that entirety of 14 hours. So we want something tell the whatever my controller to do is to start writing the data to the flash. And so an accelerometer proved to be the best component for that. I chose this seems simple enough than ADXL 345. Because of the way we designed it at eBay, this could be very easy to just mount onto the triangular prism. One thing that we need to change though is the code on the DAC or the controller. We need to for the analog signal. Then big thing is the battery. So as mentioned before, this system needs to be able to be powered up to 14 hours. Another thing that we found is that both the Arduino Nano and the strain gauge modules, I showed before, both require at least 5 volts to run. There's also a restriction on what kind of battery to use. We cannot use a LiPo battery just because of how heavily regulated it is by IREC. And then also, of course, it needs to be able to fit into the triangular prism and also connect to a JWT wire or jump wire. So from these constraints, we calculated that we need a battery for capacity of 2,800 milliamp hours. We used the lab jacks to calculate that value. We used the lab jacks current demand of 200 milliamps. Another thing to consider is that if we add extra components, they might not work with 5 volts, meaning we need to use converters or voltage rectifiers. So one battery that we came up with that essentially solves our problems is this one right here. It's a 5-volt battery and contains 12,000 milliamp hours. So it's about 60. Just with the bare bones system, we could power it for 60 hours, and it does fit within this triangular prism. Of course, that gives us the ability to potentially add more
more strain gauges since we have the extra battery. What chemistry? Sorry, what chemistry is that? Chemistry? I think it's not life, lithium ion. Lithium ion. It's in the speaker that says lithium. Sorry, it's a speaker that says lithium ion. Okay, the next consideration is how we're securing the wires. So since we have exchange gauges throughout the rocket, so we're running wires along the carbon fiber walls, we need a way to secure it to those carbon fiber walls. One way, the first consideration was using screw-based looking clamps. So picture like right here. So you basically screw it, drill a hole through the side of the aerostructure and secure it there, and then zip tie the wires around it. Obviously, this provides a greater security for the wires and for the clamp itself, so it won't fall off during launch. And also, since it's screw based, it can be replaced if the clamp breaks for some reason. Or obviously, the big con is we are drilling a hole to the side of the rocket, so it might potentially affect dynamics. And also, another consideration is that if we since we're measuring strain in microstrain, it might actually affect the data we get from the carbon fiber tubes due to changing the physical structure. Our second option is using liquid adhesives. So basically, along points in the wire, we just wrap it in a seal of glue. This does obviously it's provides flexibility in placement because you can put this anywhere on the inside of the rocket. It's also been known to help mitigate physical vibrations, which mentions system requirements review actually does affect quality of the data we can get from the strain gauges. Some cons are that they are, even though they're temperature resistant, they have a high cycle thermal variations. So since if we're going to leave the rocket out for a long time, this might cause the fluid to become weaker. Of course, we have to do testing on that. Another aspect of the fluid is that you do need to crack the carbon fiber surface before putting it. So slightly rough it just to increase the surface area and really good at. And of course, since you're gluing the wires to the side of it, you can't easily replace it like. So our decision is to use the liquid adhesives. They are much, since we get to avoid having to drill holes into the aerostructure, they're a lot easier for installation purposes. And since they help mitigate the effects of vibrations, they do help us in achieving that system. Okay, now we get to the software. So here's a pretty sick photo of some software that we use for the lab jack. So this is the Lua software. Basically what this code does, it reads the incoming signal from the lab jack and then writes that to the onboard flash. And then we have a separate script that can take that data from flash and then turn it into the correct. Since we're not using the lab jack anymore, we can't use this exact code, but essentially the same code, essentially the same functions will occur for whatever we use. One thing that we'll need is, of course, new code for the accelerometer so that we can trigger the system to start storing data. One other potential that might occur is Apple use external ADCs or analog to digital converters. So just in case, one aspect of, even though like an Arduino Nano already convert analog data into digital data, one thing that is not as great is that it might reduce the resolution of the data. So using external ADC can get higher resolution data, which is something we can kind of consider. Of course, so to do some testing with those Arduino Nanos and see how well of a microstrain we get. But that's something to consider regarding the software is using the communication between the microcontroller and any external analog digital. So just go over the compliance matrix. Since a lot of these are qualitative and quantitative requirements, they're all we with this and then slide up. Okay. So first, I'm gonna talk about the new updates on the next iteration experience that we gave them this month. So the changes, it's got a new GPS, which is actually the same one as the featherweight GPS that we used. We added a magnetometer, which is for GPS, also the common filter, important for that. New flash chip has a lot more storage, we need more storage. Yeah, we fixed the MOSFET of traces. We're able to start method now. Fixed the voltage regulator. There was an inductor, not serum, that exploded at high voltages. And we're gonna expand the board a little bit to accommodate the new GPS. Next iteration, we're going to reorder the components. We can put the microcontroller on the back, GPS front center, and then radio chip probably off to the side. And that's to help reduce like interference and noise with the GPS of the components. We're gonna move the LoRa radio chip directly onto the PCB to save room and cost. We're gonna change the microcontroller to something a bit worse, but more efficient, because there's no reason that it's as like faster as it is. Any other adjustments based on this is one before that. Then I want to make it black. And now this is our planned software work. Before the next iteration arrives, I don't know how long that could take. It could be a month, could be 2 weeks, I don't know. We're gonna implement the new components into certain codes, so we're ready. We're gonna change our data logging method, something resistant to like errors. For the common filter, we're going to test the radio within those code at long distances. We're gonna work on the test rocket and feature and test it to see whether it can detect apogee. That's to see whether it can act as the main flight computer. Another thing, we're going to test the IMUs and barometer, just triple check that they work in the data that they give makes sense. Then after it arrives, we're going to test the GPS, test the magnetometer this time. And for the eBay, we're gonna have all the same components that we did last year, with the addition of the Elven beacon, which is to help for recovery. And then that's here and the GPS. We'll take it under advance, reducing interference. And for the camera, this isn't set in stone, but I was looking at the run camera from 2. It's got enough storage. The power consumption is a little rough, but that should be a lot better running at, like that's the max at 4K. It will be a lot better running at 1080p. I don't know exactly what that number is. And it would probably need a fan for dissipation because the max temp is around the same as the ambient temperature in the rocket. Presumably there's like runtime splits in the bay. I don't know if we've tried using those before. Okay, I want to talk about why that didn't work after. Was bad. They're bad? No, we are bad. Oh, we're bad. So I was looking into programming them, and the thing I need to program Elven Beacon could also work on programming the runtime splits. In theory, so I don't looking at that. Okay, now we have a bunch of compliance matrices. I'll just spoil it for you. We need requirements on all of these. One thing I have to note though is that we didn't specify in the presentation what we're doing with batteries, but because we only recently figured out eBay components, but given that most of our components are identical to last year's eBay, the Elven Beacon, it won't be too big an issue to swap out one battery for that. So we meet all requirements on general battery. It should be able to power eBay or minimum of 14 hours. It should be, no, it will power eBay
Now, should hour to 36, that's my computer. And it, with the S1 R3 iteration, we will be able to fire in action. You will have multiple APS. You will have multiple APS. And then on the frequencies. The eBay, we're not able to design fully out the eBay until we recently got the airframe dimension, so, but we will wire it properly. Just see. No, I'm not attacking the plan.
It eventually, all of our wiring. One that didn't. There you go.
That's with the S1 R3 iteration, our GPOs will be working, and we hopefully will be guys on one pre done. And yeah, we're probably up in the middle of that's that.
Who's ready to do it all over again?
Wait 5 minutes.
Yeah, go get water, take a break. Reconvene at 7:55.
Might be We're, it's still better time, we pay for a lot of. What?
Like Mitchell like talked to me like 2 days ago. Oh, I can't.
Look at Mitchell.
It was like,
That's like accurate goals. That's their goals. Because the separate about water. If you have a truck, it'll amplify the yellow. Urgency is built. It's actually. Yeah. Yeah. That's nothing. So the time. I mean, the toughest city. Yes.
Maybe. Or the question. Man, okay. Yeah. No, that question. Well, okay. How many questions? Forgot. Or. Yeah. Oh, yeah. Oh, yeah. Like this. It's not that this last person. Oh, I feel it. I think I should have the whole thing. I think people are like. A lot of it. I forgot. So it's right in front of me and I don't remember. But. Yeah. It wasn't.
No, your section one.
Yeah. Well, like, we got. If I see it. You get it. Like, oh, yeah, we have the email.
Yeah. Worst case scenario, you could say.
I mean, you might say, you know, think it's a good idea, that could change.
Maybe something. Like any, but just.
I mean.
You know what I mean? Like,
That could be next year, if it survives till next year, we gotta do good this year. I'm going to build the still. Phrase that. Thanks. Better because that's not, that's IREC. That's right. No, he's senior, I don't know, we just don't really. Well, maybe they'll like. If we hear. Like on a model. Yeah. Or like. Like that. Yeah, sure, we're doing sure. I mean, you can do that. What? Now, maybe two. You're really even though.
no, I just do.
You're starting in 2 minutes. Finish in 30 seconds. Yeah. Not your dad. Okay.
Give me like a mind, this is. Yeah. The meter, but.
I was thinking, I might, make it flat. Oh, no.
This context, how? Yeah. If we were eating sometime.
Well, I don't feel like we're up to there.
I mean, I hope that's very awesome. No one's still. Wow. Like after the end. Is this like, is everyone else get here? Take a lot of people.
How long is it?
I am fine, I forget paid. Okay, get started. Is it not great? Somewhere around slide one. The old slide. Moderating. I want live favorites. One of the three. Like, okay.
My first comment is on slide 23.
Wait, let me come back, this is. Oh, wait, where's Steve? He got these. Okay, you're, I just want to make sure you're now on duty.
I am on these.
Are we ready?
Yeah.
I have a question.
Yeah.
What were these rules before? What did they change from?
Okay, dynamic stability, so the requirement is to be 1.5, and specify 1.5 broad. Now they said this weird wording, which we
They're probably gonna change it before the action.
We did want to just like. Account for that element.
Yeah,
Or
but-
that.
best understanding of it right now is 2.0 for the full flight, without the broad.
And for sure. They said 2.5, like I forgot to find the word, it's in the Discord. Someone asked a clarifying question that they debate or two, sorry. Yeah. Keep answering that question.
So, yeah, in 75, that's just a new one. Like that, that wasn't a thing before, and stability and people coding all over this. And then, the last one, it used to be shall have at least 50 feet per second, now it is shall have at least 82. And then the should of 100 is same recommendation.
At me, I don't know who mentioned this student, but I was told at one point they're now actually required to test for failure, is that true?
Yeah, so, that's not a design thing, it's a testing thing, but you have to calculate the shear modulus of your fins, experimentally.
They say you can do math is gonna be paid off.
Yeah,
I can clarify that 1.5. But like. So it would be made up, yes, you're right. The clarification is, so to clarify, team goes super light, Mach 2.0 however off the rail, the teams under Mach 1 to 1.5 off the rail. That was agreed to by some as the volunteer.
so yeah, I'm sure there will be more clarifications on the fin testing thing. If we are gonna test the failure.
You should include that if you're looking at. Like, it's not design, but it is an important thing to know at this point in time, so, yeah.
Next slide, about.
I have 26. Okay. It's not like super important, but when you call them charge wells, at least to me, that kind of just implies they're on a whole bed. Oh, yes, floating, or like well dip charges, or something that indicates that. Floating charge. Yeah.
No, I just want to confirm the cost. Essentially on this design, the payload, what. But all the things about there, like there's enough.
Yeah, I don't know if it's good, but the.
Like if you were to make that couple of solid with the internal diameter, that could, and that made it cheap and how much.
It's another the number, I believe is 5.606, which is the same as last year and it last year. I don't remember the exact. I really. So, yeah, I just say.
When we do these detail side, make sure it fits.
I mean, I know the position.
Yeah.
I like to put the two.
The fiberglass as well.
Oh, it doesn't have fiberglass. Sorry, it does no, this one does not have. This one's top fiberglass. But the recovery design. Any other questions on this side?
Is this the nose design you did choose to use?
This is one which is.
Wait, that is a fiber, could you repeat that, does it have a fiberglass up there?
This one does not have a fiberglass.
The nose cone itself is made of.
Yes. Okay. Seven. Yeah.
That is not accurate, that's just what's blocked. The like, the other three are great, that packing scheme though, like. Where are your lines, where's the attendee, where are quick links, like, if you're gonna say packing scheme, make it be an actual packing scheme. This is not. No, like that thing is that's honestly more of a detail design thing, but like, just either have it be a real thing or don't have it.
Broke. In a separate deployment bag, is it just like under my flap, separate as a separate.
That's new this year, it's,
Okay. Because here is, that looks like maybe it could be like just either that flap on the deployment bag.
and that's what I say, make it real or don't have it.
Yeah, like you can just say that each have their own deployment bag and. That diagram.
I know so.
I mean. You're wrong. But it's someone else. This thing. Right back, right? Yeah. Provide to it, like that should be a change. Like any questions from the rest of the sheet?
Kind of related to what Andrea has, is you said floating charges include more complete combustion than a charge will. Is that like really true? Is there
If you do
less than
it,
five, less than five than a charge?
If you do find.
Aren't they like the same then as charge wells in terms of how complete the combustion is?
The way you have it can be different and it does improve things. Yeah, that's something big deal, it's not today, fair. Is somebody being a scribe for these?
Yeah.
Okay.
Need to clarify that we will put something in there. For
Oh, yeah.
that, right, you're going to everyone. Yes. But make sure you change some. I mean, I guess they're not going. So.
Was this one with the fiberglass?
This is the one that.
Okay, so. You're going to have an issue, I know this is not like a conceptual thing, but when you get more into the act, like. Average part, fiberglass and carbon are going to have different thicknesses. You are going to have either a separate coupler mantle for this. Or. Some kind of discontinuity, for the thickness between the nose bone and the body tube. And you're also going to have less space up there. If you use fiberglass.
Yeah.
It's not gonna be where.
Yeah. Okay. Any other questions? Oh, 30.
Yeah, so,
Yeah. One.
One, we say that there's a limit on the eBay space, why? Why can't it just be logged? I mean, obviously that would change the only, like, what's the restriction, and like, literally, it's impossible.
Could be if we go back to the. You could. Just make it longer, but that would.
You might hit the point where you need to, but if it's acceptable.
Yeah, it would get towards the limit of. The body makes.
It's one body feet. Just
Why can't the nose cones total? Like, why can't the nose cones think that could be long with you?
This is human design.
Yeah, so if you should have, I don't think that's you can welcome to keep my opinion, that that's not an issue. This is, you can't get along with it.
Yeah.
Okay, I think that's.
I think we-
Anything else on the slide?
What shape are these parachutes?
That sounds like a deal.
I mean, you have the CD on it.
It's not that influential or physical, it is, but yeah.
Okay, but that's in the on here, so
It's still something like a deal. I did your top port number. So. Don't use that, yeah, all through these all the time.
I'm getting the entire slide.
Yeah.
Having one group and a main is your acceptable. Basically, I mean.
Yeah, so. Two things, for kind of general to all of these. You've had like other diversions for your scope designs, but not for any other ones that might.
It's fine, we did, if it wasn't anything, we don't have it, but we did do things for all of them. Yeah,
I'm sure it would get it very.
I think the only one that was different was mine, and I had to make these, I'm set it in the ponds, mine, I'm not going all the way down right now, but I had to make mine like. 0.025 thicker to account for the so, but and then like we did do that.
So the payload and measurements defect, just slide out the top, that, yeah, okay. So then, if you're having those come out the top. We wanted to have measurements measure like the main body tube and like down by the pin, right? How are you going to connect the connector that deep into the?
It could just be wide as slack.
So you're gonna pull a wire all the way out of the tube, put it in and then slide it all the way down in? It's a lot of excess wire and it's gonna need some space to foil.
Or just use another. So I think that's a.
If you have to slide this thing out the entire tube, like anything under it is kind of gonna suck.
Use another EPA.
That doesn't solve the problem of reaching all the way in to connect something, we're having a ton of excess line.
I think this would be.
Yeah.
Yeah.
We'll keep that in mind though.
Yeah.
That's also.
How exactly?
But
Yeah.
if it's easy or difficult to do is definitely something that is considered at this stage.
Just make sure the open rocket system doesn't let you do like geometries, so it's a tube and then a cone because it has to be modeled that way, and open rocket would be a certain shape, the last year, that's correct?
Yeah, you're asking about like the little.
Yeah.
Like these two right here and then like this tube right here.
Yeah,
Yeah, like that's, it's like,
that's it, if you have to do it that way.
yeah,
You
yeah,
have.
yeah. But those are parts of like, if you go into the open market, that is like nose cone extension and hotel extension, so those are part of both of them.
And then, is 55 the longest tube you would roll? Okay.
Yeah, because of the balance in this one, I stretched it to the limit, and that's why I both tell those. Those were, so.
Yeah, because, you're going to have issues finding reasonable price bills are going to be on.
Yeah.
Okay.
The other is, we're not like,
Yeah, so
the other one is people.
We tested under 55 or 55.
So all these single piece tubes are smaller than the manager that I have there.
The manual 60. 55. But like, that's like the space now, so. If we could roll from 5 to 5, if you're winning. Cool, anything else? John? Anybody?
Yeah. So, stability rate has, or on this one, this is 3.09 static. Those are all static stabilities, is that 3.09, just like the default ad hoc looking three that Open Rocket lists?
Yeah.
Okay, so that's all static stability.
The stability rate?
Yeah, it's just all static.
The stability rate is taken off the,
Yeah,
Oh,
it's
yeah,
not static stability. So. If you have listed as static, it's just that ad hoc three.
yeah.
That entire thing is just what those static stability is. At various points in play. Correct that. Waiting for a long time.
38. Well, I just, uh, 97 degrees, is that an average, is that like a low?
I really average during the, like, high during the month of June.
So 97 is the average high during June?
I believe that, and we use the same as last year, but I
You
found this
should,
simulation of last year, so I believe that's what it is.
you look into it worst cases, yeah. Yeah, because the colder it is, the lower you go. So we should have like, don't be like absolute worst case for the last 50 years or whatever. But like, maybe do like 25%.
What's the average temperature, but. Yeah, the earliest one.
Yeah, we should put it.
Yeah, flutter on my end and you're. This happened.
Yeah.
Yeah.
But for me.
Cause that's when, yeah, like during the day, the temperature varies a lot.
This is a comment on basically every single graph you have in here. After apogee, we don't care. After apogee, recovery devices have deployed. The flight is basically, it's effectively over for like the stuff that we're talking about. Every single one of these. Just truncate it down to like. Just before apogee. Like
Yeah, over one for an average plus a second.
yeah, I bet like.
You'll actually be able to see the detail in our acceleration curves and stuff, it's like how it's.
That is a comment for every slide, every slide.
Somebody asked questions for time, sorry. Back that I saw.
Yeah.
Oh, that's something crazy. On the. You can recreate it around there, so you can recreate it around the arrows if you're. Like you don't need the. Each of some. Same. Oh, yeah, but that's still what we're. Yeah, but just like do it. Yeah, that's.
We all did do. Or was, yeah. Back when I did those, that's what I did for everything, it makes it really big picture.
Yeah.
You can put it out. Yeah, like.
Yeah, that was my comment.
Right now, there isn't a place to mount it, because there isn't thing to keep the nose cone tip on. You will need that, once that is added, you can have the ballast mounted in place. And like, it's just a nose cone tip and nothing, you said, oh, we'll have a bulkhead there, in the second, this. You'll have a bulkhead there, that becomes the ballast. And then your con about if the nose cone comes down ballistic. If it comes down ballistic, the rocket's already. Like.
The thinking with that is. The thinking with that is last year, the only thing that was undamaged was the nose cone and the eBay was said to be reflyable.
But regardless, if I'm done ballistic, I wanna see
Yeah.
what happens.
If there was a
Yeah.
bat,
If you put valve right in front of that, and got right for the.
Well,
because the way that the way
Like,
that-
you didn't follow me along, like, you break everything, you'll not feel it.
my thinking with it was
If you
the
put somewhere else, you should.
yes,
Yeah, I
I think we should be focusing much more on make this thing calm down ballistic.
But
well, at the very worst case scenario, we want to at least have our data. Think about when Helios came down, the threaded rod got bent. Imagine now there's a ballast there. Like the top of the EV cover came off. So there was a ballast there. Got came off, yeah. So the thinking of that is like, worst case scenario,
Well, also, it's just something to think about, if you were to decide to switch to the second company design, then having the nose valves wouldn't be an issue. Because then there wouldn't be a space for the nose valves ahead.
if
You should put the valve on the.
okay, yeah. But okay. Another note.
Oh, yeah.
Yes. There is no other.
Okay, you put them around the center and.
It doesn't need those dedicated payment, but if you can put it in.
Yeah, with the chosen design, the ballast would just go around the CG, which is good. I think there's actually a center ring on the CG.
Yeah, so just all the big pieces of
Okay,
steel
or
that.
that.
43.
You have these.
Yes,
Something to note, since I don't think that you're involved with this particular part, my freshman year, I believe there was a specific issue where over sanded the outside of the boat tail, so profile longer matched up with the boat tail, and that was a significant issue, so that is something to be aware
we have had, I have had extensive discussions with Julian about making fins better, and this body also we didn't get into the fin manufacturing,
of,
obviously,
but just
but
keep
Yeah.
that.
that it is very kept in mind that we are coming up with a better way to manufacture fin pan and stuff like that.
Are the fins fully on the angled section?
Not in this design.
Okay.
I can blow this up.
Because that sort of step, I think is a lot of the difficulty. Because we had it and it's just
You could,
that.
I mean, okay, so basically very quickly what we're thinking of is some way to quantify the radius, because the actual hotel isn't a corner, right? It's a little bit, it's rounded. So some way to quantify that radius or something like that, and then either like, or just like manufacture the fins that way, or give extra material to the fins, and if you really careful, like try and stand them to be as close as possible. The other, there's more considerations to do patch layer, other thing. There's lots of ideas to make sure that the contact of the root cord to the bow tail is good.
That's why I noted in the manufacturing that are gonna stand and have to be.
Yeah.
To the best of our ability,
But 46,
I did,
7, 48, 49.
skip on the
Okay.
pros and cons.
Hey,
I mean, just like in general. The like last couple, we're like this last design is like the same as the one here. They're not very different.
Yeah.
Like you went over the differences in like a balance and the difference in like your nose cone like layout. And like that's it, and there's just like another one that's like the same. Well, so but
I made mine one body, they have the conversion of the,
No, yeah. Any other comment?
I don't remember reading this, the first transfer bulkhead to take load off of boat. Where is that bulkhead, what does that mean?
Okay, go back to the diagram.
I
Lead.
This bulkhead.
Oh, yeah, that's the part of the start. Okay.
Let's transfer to board floater.
Yeah. The
Double check that.
it takes the lot of bulkhead, of the bulkhead. Yeah.
But we assume the boat would just tank it, which like historically,
When it lets air brakes flop, so.
yes, but also we don't really. By that, so that's.
The boat tail could totally take thrust loads. Yeah, lifting.
I will say this too, when we were doing the math for this, because we are not cutting out our brake flaps, we send it the less thickness. When we're estimating the math, yes. It's alright then.
But that was I think it was 3 lane.
It was like 65.
Most of it survived.
Yeah, it's both types is fine.
Anyway.
On it.
So what's the note here? Sometimes we'll get by.
Yeah, kind of why is there one? It was just clarifying what exactly I meant, and yeah, I guess then also. Is there a benefit to putting this thrust through something good? Is, can you put your thrust through the forward closure of the motor or yeah? And then if you can do that, is there a tangible benefit to putting it through a bulkhead up top? Compared to just pushing it through the fin can, go tail, whatever, just all into the day, like we have.
Any other notes on 53? Oh, great. 54.
What's the next slide you want?
Okay, yeah. Do that. Oh,
All the way, that's good.
oh, we don't care about it. We don't care about it.
It's a requirement.
Wait, sorry, I had,
Oh.
and it's generally 62
Dude.
just write out the pros and cons. Like, I'm not gonna remember all of that, and it is a copy paste.
Okay.
Would you guys 77?
Yeah, but it's just like, yeah. Didn't we make a requirement for the team for dynamic stability? I know we talked about.
I can check that out.
I don't think we were actually.
No.
Okay, well, we should have, I thought we said we should. But
I said we should, it's just not done it.
yeah. Anyway, like you talk about it. Somewhere in there, I was up before, it's kind of, you talk me, so it's fine, but. Yeah, but then actual dynamic stability and not IREC bullshit then.
We discussed it, yeah.
Yeah, the only dynamic stability mentions in document is where IREC says it, and it's just factually incorrect.
Yeah.
And I just other things, like since we know this, I think it wouldn't be. On these five, but we don't on a control surface, even if I make them, because it's not a control surface, it's not controlling the market. It's totally.
No, we're
It's
not.
aerodynamics.
Yeah, it's not a control.
It's passive control, not having.
It's not control.
It's
not a control.
Next slide.
This came from an air brakes system.
Next slide.
What's the new efforts come? How do you trade them?
Eight is my next.
I trade, oh, yeah, I've figured out about this.
I have a lot of questions.
Can we?
The first one. How do you choose any of these not that? How do you choose what your categories of importance like are rated as? And how do you choose your cost? Specifically, I have one really big issue because there are a lot of grades up there. You guys found that IREC points that judges have not been consistent. And yet you said IREC would cost you one. And that's what it is when we found evidence that the county team
you can IRD, you'll be perfectly fine, with the same amount of that sort. So, like, don't carry different data. Yeah, I was just, that's why we didn't get past like a lower score, because it is like possible, but I know it's not like a cause and effect thing, but the like, it would be kind of.
For design. Like design, what is that called? 30 of them had extra tubes. And it says in the detail, but that is how it's called. So
Just because the top 30. It's not by that.
it does not.
Yeah, so your data.
My biggest counter argument to that is every single rocket that we've made since I've been here, we've scored very well on that category. Half of them are SRAD, half of them are COTS. We make good enough rockets, it doesn't matter.
Also, I would use that for two. That's a question.
Yeah.
Did event horizon do exactly as well as helium?
Yeah.
The shittiest tubes in the world, arguably, and. No, but I mean, like,
Yeah.
event horizon, objectively, event horizon tubes were really shitty.
All of,
Like, technically, they were bad.
and like, I don't, for this, I don't really care about how other teams did. The evidence that we have on our team is that we can make good enough rockets.
Okay.
That we score really well, no matter what.
Well, you know, like, you're not proving that there's a correlation between high or low IREC points. And for us, or even for other teams, because you're saying the top 40 team did that, and like, that doesn't mean anything, that means there's still 10 correlated, other people said not that, big score, yeah. Yeah, do that. Well, I mean, but if you have a point on that,
The teams that are confident enough to make their own tubes, I'm not gonna be confident enough to write into the report. I don't know, probably not. But like genuinely, just
It's like not random. It's not pretty.
well, if they don't.
One of the other big things for this, your cost and customizability for veteran. You give one of those two, not both of them. If you want customizability, you have to pay a lot for them. So. You get one of them, not both of them. You guys have said like previously that we're gonna use the same manual we did last year. It's great, so your cost is way lower. But that locks us in. So, yeah. That's my whole thing. So like, yeah, so like it's
only get out of.
yeah.
So the entire graph is very,
Yes.
like, one.
The light performance. I agree that COTS is lower than SRAD, yes. But you guys yourselves showed you can get to 30K on a COTS too. 4 out of 10 is just like not true.
I would genuinely, we've got a metric of like what is the 4 out of 10 important? Where is your rubric?
Yeah.
Or did you say this feels like 4 out of 10?
Yeah.
And then professional.
Also, I would wanna know,
Yeah, but like, I wonder the thought that goes into it, if there is actual thought, and you're like, no, this should be 10%, and this should be 5%, and like, if you're actually thinking about it, you're like, yeah, I have 15, 10, like, 6 takes it, word right.
Fine, but there are behind me.
yeah, I would like to know for the costume, like looking at these comparisons to get some more like. These are more of a P chart than in the trade study, I feel like, I would want to know, get some numbers of like how much would we need to reduce payload mass, measurements mass, or to get the amount of wiggle room that we're comfortable with on the cost based market. Like, because those are very high upper bounds, like, we're probably not going to go up to those upper bounds in terms of that mass. So what upper bounds could we have if we wanted a cost market to descend to 33,000 feet in mass area?
Yeah.
Okay.
Yeah, there needs to be more spreadsheet and less We like digital better.
Because it's more like a,
Yeah,
great.
you're like half.
I am also,
I went over this like with numbers that I thought were more accurate and, you know, SRED still did win, but it was like, what was it? It was like 60 versus like 58. Yeah, 59.5 to 60. Yeah, so like I think your ultimate decision works. Just there needs to be more concrete justification for a lot of this.
I have a thought of points wise, I think you should write it that way. So, it's very like,
Yeah.
it's very easy to misinterpret this, like these numbers as like. It's a 4 out of 10, but then it's 60% of your entire 10. So, like, it feels.
In my mind, it genuinely makes more sense to do everything out of 10 and then multiply by the percentage, but maybe that's just not my brain.
I mean, as for
To what I'm saying there, do this on a spreadsheet, so you have your like base score, the multiplier, find an actual number, like for.
they also say you
Yeah.
should,
Exactly.
you. Hey. For times a little hard for flight points, for IREC, and for IREC points, and for cost. Those are all things that are mostly based on numbers.
Yep.
You should be able to do really good, like, statistical analysis, like on flight points, you got every single team score. IREC gives you every single team score. 800, some, like, that's a lot of numbers that you can look at. So those ones you should be able to. Have a very good reason. This is a 6 out of 10 because. Teams follow that.
Other than it's not a great study.
I think it's great. Yeah, I do wanna say, like, this is, I think, the most real trade study we've done. It's like, it's the only.
Yeah, but don't look at it.
It's an actual great study.
Yeah.
There was a thing that we
Can
were.
we keep the link on the?
I'm very glad that the bulk information about this excellent team, like, development didn't make it chart.
It is worth noting. But
And
it was not.
We didn't have it in the report.
yes, and I'm.
But it should be said, because it is.
I think it's good to mention it and
I would just love to have like, at least those descriptions that you put by the shot at the bottom. That would at least that would under that the first page.
on the presentation stuff, okay.
Yeah, definitely.
Yeah, I wrote these out,
Oh, yeah.
there still is a little, you'll see if you read down. This little vibey, but the reasoning is for now. Yeah, that's it. Very good.
I think we covered it.
Yeah.
You got the feedback down?
I got a lot.
Cool.
It's great.
Anyone, be great.
And you paid. You paid.
Say anything about why you chose this one particular.
Oh, yeah, you did.
Yeah, you choose this one.
It goes to the highest energy. It.
Why would that important?
Because it gives
Also, the two ballasts were, we thought of, like, when you, I didn't wanna mess with, or we did not wanna mess with the two. Like, variables, like, messing with apogee and stability. So, it was just a little simpler and Robbie has.
also.
If you lose it,
You did, and we did.
Oh, well, that was my concern.
So, the other reason, is this is the shortest body tube, and namely the length from the top of the body tube to the thrust center bulkhead is not the length of the arm, so if you've gotta reach down there, you can, and that's really nice. And also the fins, I believe, were the smallest.
to that point about ballast messing with stability and apogee, that's gonna happen regardless of whether you have a nose ballast, not because. The mass, like, we can have things be heavier or lighter load wise, but like the rock is not gonna get uniformly heavier uniform like. Like if the payload is heavier or light, that's gonna move the stability. If the bone shell is heavier or lighter, that's gonna move the stability. which means if you only have a valve at your center of mass, then you can't correct for the spilling thing.
And this is why we implement the balance after we take them on that.
Yeah, but my point is like, if you're located, like, if for whatever reason the design said the valve will and can only be at that second settling lane. Which I know it isn't, but I just want to make the point clear that your ballast is going to change your stability no matter what. You know, like it's going. Okay.
Especially throughout, like, at your. Yeah, it's gonna change like the shape of that, like, the line. More than you would think. But also open up the same thing today. Yeah.
Yeah, like it's not, it's like you're gonna have to do it, but just don't be afraid of putting the balance somewhere else, because like you're going to have to track the change no matter where the balance is.
Yeah.
It's not extra simulation, extra manufacturing complexity, sure, but it's not extra simulation.
Big balance.
Well, I mean, but it's like that, there's
Okay,
flexibility.
next slide. What's the next slide on?
I would pretty set.
Yeah,
I also pretty set.
yeah, these people multiple things.
I think there's 4 issues on our rocket. We personally have fucked up. Yeah, like, this should be like a gigantic spreadsheet.
What should be like a whole other year?
Yeah, the complaint I got was I couldn't read any of this shit because it's like 50 of them. So like, yeah, closer to them. No, there needs to be someone. It's like what you have is. Yeah, these are all good, but.
I think so, for example, like for side pairing, maybe like top 10, top 15. or something.
Yeah.
And then like, but then one for left.
In your presentation. Include, the top 5 or whatever, but then have like a link to say, hey, here's the. You could probably come up with like 200 issues.
We don't need to do too much.
Yeah, it's like you could.
And also I want to be the most. The actual like.
Yeah.
Yeah, like an.
Yeah. Yeah. And it's like. Oh.
Yeah,
Yeah, cool. You actually have it. Fucking sick. But that it don't. Because air density is a factor for CML, it will change throughout your flight. One thing that rides account for. So you can do it, rocket to flight. Well, versus time essentially, as you for.
This is your the normal force coefficient of the function. And like, what is?
It's the derivative of the.
Is the derivative?
Yeah.
Okay.
Also, and the number you're looking for is above.
Yeah. So explain in alpha and beta because it's the first time we.
Yeah.
And we should, since it's the first time we've done, we should explain them.
You did.
I mean, like, well, maybe,
Like in writing?
yeah, I'm like, it could be.
Also, like, for later, do the other stuff, like in. Yeah, one of. Or. Justification for all of these. These are design decisions. Why are you making them? Like that,
that's not.
yeah,
They were, I think,
yeah, that just like for each one of those. You have to be solid. Cause yeah. Have some, yeah. These also using pure carbon pins. The way that we laminate carbon on, and we can also just do it without sheathing and shift on the layers, just get the carbon plate. And if we need to test thin materials anyway, we can do the work to quantify if that's better. I suspect it would be, and if so, that would be other.
And if you're gonna do that, you should make that purchase list by, like.
Yeah.
yes.
Yeah.
Like buy.
Yeah. We're gonna buy it.
Oh, wait, that one.
Well, we might buy it. I'm gonna buy it.
Okay. So.
Okay.
We want to take one.
I'm gonna get
one. And we're gonna do a marathon event.
I'd take a step and look at it, but yeah, I think so, it's different.
Yeah, it's like the, or vary the, you're gonna vary the, right?
Yeah, you wanna vary the angle, but that's not gonna impact like.
If you're making a plate, though,
So it's like a flat layer, the bottom of the plate is.
Yeah. I would want it.
The secret fun fact. It's an I-beam effective. We're bending stiffness, the center of it doesn't really matter. Yeah, it matters less than you would think and make, 80% of a G10, but it matters more than nothing. The original motivation behind the G10 board is just, we're gonna do the composites, we don't wanna do a bunch of layers to deal with that. We are no longer new to composites, it's probably a thing we did try, please. If it doesn't, we know that, so whatever. Yeah. Don't, I suppose, just don't, yeah, you got test things. Yeah, it's, well, if the rest of the things. Yeah, exactly.
Cool, next slide, is there anything else I'm doing?
So the way you're talking about how you're making everything except for the layers of carbon that you're putting over it, you're gonna talk about how you're making everything. You can talk about, because we used to laser how we paint it. Right? And we couldn't anymore.
Carbon after hours, we cannot laser cut stuff out.
This is not even detailed, this is orange. Yeah,
That's true.
Why is this here? Like, yes,
Yeah.
and what, like, good plan, like feasibility and what has to.
I guess like.
That was
we could
about-
design, you could-
was the-
Yeah, it's like, hey, can we have, I mean, it's like design, last, that's the last.
Yeah. Oh, that's good. No, I think it was a two-day program. Yeah. I thought.
Like, explain just like. You have a
Detailed thing.
Yeah.
But I don't think like, you see what they pay out there.
I don't.
If you were like, Rebel Root very new idea. And you could say like, hey, we made this, yeah. Like the first thing we did at our composites, we had more detailed info about them, which was justified that year. Yeah. Down there, yeah.
Oh, I think, yeah, any final question?
No. Well, but
Yay. Birthday.
I would think most of them are manual things, but.
Good job, guys.
Yeah, thank you guys.
hey, your timeline's looking at this.
That's what that's
Thank you.
You gotta include.
Yeah, what, I'm ready to see on this.
Good thing.
Nothing before, I was just gonna see, there's a lot of extra.
I'm gonna go grab it.
Good try.
I have,
Is that
even nitpickier thing, you just get this in light mode.
Yeah. That was also my comment, yeah, dark red and blue.
Yeah.
Backgrounds.
Right, yeah, well,
Works, but I can't hear when it's like in front of your face.
It also helps when you have a good.
Yeah.
This.
In mind,
You know, the vector is.
so I know what we're.
Yeah.
Yeah, I see a triangle on this.
Well, it is the main.
It's a circle thing.
Oh, wow.
Wait, doesn't really matter.
Lacked so much coordination. That was impressive.
Right, but we're not even allowed there. Okay, if so, you can make this a lot shorter. Like the eBay.
That's true.
And when you do that, you should look into 3D designs, both for the sake of compact design and for the sake of manufacturing. Because you have to machine all three of those, you have to machine the brackets, you have to assemble all of it, which is impossible, of course. But it's really fun to make go, hey, Ron, print some shit and it's done. No, it's awesome. So do that. Or
Bring Caleb for that in the base, the only good thing is done for the stage.
You can't, like, it didn't work, that's.
Any other questions for the slide or? No. Next slide. Same things about. Oh, yeah.
On the triangle.
Yeah.
You do a lot of beautiful things around the triangle. Like,
As long as you utilize the inside, not really.
well, nothing in the inside of the triangle is going to be triangular shape. That is, you're gonna have like.
Yeah. There, I remember it's like we've done this, like this idea for the like main rocket eBay. It's like, but still, it's because a lot of the stuff we use is thin. So you care more about like surface area.
Yeah, no, I agree. I would rather I'd rather have two parallel planes. That's an story.
Yeah, but like.
That's what is that though, but I just wanted to point it out that.
Yeah.
I wouldn't be dead set on the triangle, especially because batteries usually have.
Well, it's just like that easy, like spot because like we had like an example slide and it's just like
Yeah.
yeah, but you can't put a battery inside.
Yeah.
But, like, you know, this is the-
This shape also doesn't matter.
It doesn't, but I just wanted to.
No, details. I mean, like sled versus 3D print, yeah, even.
That's what I'm saying.
But beyond that, it doesn't.
Like all these different things and. Let me say, 8 acre small, sandwich.
That's a detail.
I know, but it's gonna have some dimensions like that.
I think the big one,
Yeah.
don't have it.
The next slide.
I have 111.
I have 110.
110.
Then anything for 110?
So. You're saying, I like, the idea of using the cable is good. More generally, it's a D sub connector. If you need to use different amounts of pins, you kind of want to know that.
Okay.
Specifically, I looked it up, EPA uses EE15. What's the name? It's 15 pins,
Okay.
E is just like that specific shape.
Okay.
So just other D sub connectors might make more sense if you determine you need more or less pins. I mean, there's not really a downside of more pins than you need, but if you find out that you want to use more pins than you have in that, you just get a bigger D sub connector and it's effectively the same thing.
Like, for example, if you've ever seen like a sewer, one holds it. It's like they look the same, but just different picture.
Oh yeah, old parallel ports are the same kind of connector, just long.
I would have one of those, but.
A couple other comments on this is. Just some things to keep in mind is like, I would have the female side of the VGA connector on the bottom. So that you don't have exposed leads once you separate. Because otherwise, like something is theoretically short the pins. But if you have the male side at the bottom, like the bottom or the image, right? Just thinking about that as well as. As well as making sure that you won't have any issues, but more importantly, that if you have like the data things, these signals and doing stuff, whatever it's doing, and all of a sudden without warning, it just. Lose weight like 10 different connections.
Yeah,
right?
be sure it doesn't burst your.
Yeah, like make sure that that can be a hot unplug without causing any issues.
It's sort of a similar thing you might put in like a little 3D printed guide, I guess, to make sure they like separate as they should instead of like steering.
The metal housing on it kind of had that.
Yeah, didn't do that, but.
BPS did a much more like energetic.
It's good, honestly, however, I would need a little 3D print,
Yeah, it's pretty.
not a difficult.
I think it's a lot more important for integration, so we can not have to flex around with getting them to line up. It is actually as a difficult.
Yeah.
To get these like parallel, what do you call piece of connectors?
Yeah.
To fit together unless you bring them together. That way, on top of each other. So if we're trying to bang like possibly off, especially given that we try to completely fit to the friction bits, usually like, yeah. So you know, like thinking with having a little notch like we've had in past.
Oh, like a plotting.
Yeah, like talking on it, or it makes the back lines up.
Also, the old is
During it all, a tiny amount of slack on. Of slack or like not securing it like an connection point. That you might have to like think about like what is your slack better, like do you want it not be secure at that point? Like be a little bit.
That's, you know,
Yeah, no, but like I'm saying like that is another.
You're transmitting data to the node stone, correct?
I mean, sure.
I mean, collective impulses don't go away.
Sure. The idea, I assume, is the node stone is fiberglass, it's a train.
Oh, there we go.
No.
Yeah, read it.
Oh, this is just string gate.
Yeah,
Oh, never mind. The string gate is that high.
I
Because
want to
they
put
said
it
off
elsewhere.
there, like, they could be. They didn't know what the. How much force you could carry is good for the case.
Not to scale, but it's bad.
Basically.
Any other questions with the slide or move on? Okay, what's the next slide?
That was wonderful.
11.
You mentioned that like, I don't know if it was here, but like, oh, it's a different system to control upper and lower. And that's like redundant. Some redundancy is nice. It doesn't necessarily have to be that way. You could have like 2 strain gauges at each height in 2 different systems. That would be a lot of components and you might not want to do that, but like. If something, right, like say you're on Windows 10. Your stuff just doesn't work. Yeah, for like safety critical stuff, that's like explicitly. You guys aren't allowed to do that, but I would give some thought to if you want.
I would actually say more like make sure to think about redundancy for your data store.
Yeah.
It is a very real chance that even if you don't use like an SD card in a slot or something, that something happens to whatever thing you're storing your data. So like make sure that there's some redundancy in it.
Considering, like, even if it's not, again, not slot SD card, but having the data storage device be separate from the control point, that might happen, and then it can be like some sort of, well, like, no, not necessarily, but some material that hits the logic faster than the data in that little black box will stay on.
That connection between
Like,
whatever DAQ device we use.
yeah, to the DAQ, and from the DAQ to some external device, that's the equivalent safety.
But I thought we were trying to avoid like having that wires.
I don't think the wires itself is the SD card, but what in fact the SD card interfacing with the SD card slot is another wire.
Oh,
Not like we have wires all over. Like if we put from wire, then not anything.
This is kind of I don't know whether to do, talk about it here or later we talk about batteries. What's the voltage aim on the now? I know.
so you looked at actually, I assume you saw a voltage in that. I'm pretty sure that's talking about the in. Yeah, well, no, that's what the application was for the analog or digital inputs. There, you scroll a little down, it says the power supply is fine. That's what I remember I saw it, so like.
The power supply is fine.
But I'll check, I'll get back to you. Input voltage is 7 to 12. Yeah, that's the. No. No, I'll get back to you on that, but I think there's something there, whatever it says 5 volts, but sure. Okay, any other questions? Okay, next slide for question 112. So, why do you need so many pins? Like, why is like the extra pin is kind of procure right where I have all dirt codes. But like, why do you need all of the extra pins on the DJ cable? Like, why you ask this already? Okay, well, yeah, okay, cool.
Well, I would want to see like a definitive minimum amount of strain gauges you need to successfully get the data you want to achieve, as well as less critical, but if you could define a maximum by like this is too many strain gauges, like we don't have enough amounts per volume, it's like, I would like to see a minimum maximum number of strain gauges. As well, I would like to see how that number differs if you use the same gauge, right? Because like you mentioned that these ones measure in 3 different directions, so you can get the XYZ coordinates of the graph, right? But if you need to, if you wanted to do that anyway, then you still have the same number of the smallest strain gauge, because you have to put units down there. Like you figure actually why your savings are going with this one, because it's all on one board. Because we still need to have the same number of strain gauges in both directions. Yes, same data from both sides. Yeah, exactly.
Okay, I think like, I did mention this, but I mean, like, of course, the one drawback using the rectangular websites is that you only get to train one.
So you weren't planning for the rectangular ones to put like the like put 3 of them in one spot and then.
Yeah,
Okay.
because the main idea of this, maybe this series is just we get a general idea.
Okay, okay, like, I'm not saying you have to, I just want to know what, if that's not something you're planning on doing, say that we know in and out of stuff, because that helps us understand why you might choose one design.
So going to the slide or not? Okay, with slide 16, I'm 115. What is the max sample rate possible with the microcontroller? Really depends on how many strain gauges we use, which is or not a determined number, but we can definitely have okay. And then also, if you said Arduino Nano already, why are you saying 64.1 here? That's just an option. Oh, but like it's. Okay. So like I'll get it. We'll get it. We're gonna order them. Say now. It's probably before, but
It's not. The parking. They keep mixing up me and Shelley. This is not like a hiding.
That's we Kelly. Is that you?
Multiple different people.
And I was bummed. I did.
Did it because she thought and Shell just replied. And just replied to it. Right.
You want to avoid external SD or external vibration.
Yeah.
My understanding is like the pads can vibrate loose, and that is what messes up your actual data transfer. I would look into like, can they be soldered in some form or another? Yeah, either by us or from a vendor or anything. Because SD cards are cool and useful. So solder them flat. Like whatever the connection is that allows data to flow from one to the other. If that is what vibrates loose, just do that connection with solder.
And we can desolder to be.
Yeah. I don't know how easy that is or
Double check that that's the only consideration. Because because everywhere I say, like
I mean, I do know that in the run cams that we've used, I'm pretty sure the SD cards have broken codes that have been like unable to read data that I know was on it before.
Yeah.
So like, I think they have like been broken, but that goes back to what I said, is like, we have an internal solution, I think we should, because I know we run into flash sites when it's stuff we've actually seen in the past. It's protected in some ways, but listening to the hologram. And just also, as a side note, if you do something like that and have a black box, if it's in scope, and this is like an extra, it would be neat to record like the data we get from Arduino, like velocity acceleration, just so we can have it as backbone if on some stuff she wants. No extra senses, but in whatever senses we have, and help can tell us how the backbone moves. If there's enough like storage space for that code, you might as well save that data.
How many strain gauges were you thinking about?
They only got that.
Isn't a lot of it's
Yeah.
you're like, let's say each like strain gauge measurement is like 4 bytes.
At 500 hertz, that's a lot of data.
That's already 2 kilobytes.
This, you have like. I forgot how much storage it was enough to reach it. But like, that's assuming that IMU works, I don't know.
Yeah, so.
Actually, okay, I can say, because I've done this map, it should be enough, because it's not like most of the ADCs I've seen, it's not actually gonna be 4 bytes. Like if we're just using the argument now, it's 12 bits. If we do this, yeah, so that's why we were thinking about doing an external ADC, and that would be like 24 bits. And with 60 megabytes, we should be comfortably able to get all the data up until apogee at like 500 hertz for like 10 sensors. So I've done that shouldn't be. And we can always do some sort of compression scheme, if that's really necessary. I've thought about ways to do that.
Any other slide? The next slide. 160. Okay. Your thing about open on the DAC will be to account for the analog signal. No, it doesn't. That is an SPI accelerometer right there. You don't need to worry about that. It just will say, give you, spit out a number.
If you're using Arduino Nano, instead of getting an Arduino Nano, you have to one.
And then I think that I can find that.
Yeah.
Yeah, but I'm not here. It's gonna be about here. Yes.
I think he looked into a protein line off the shelf. It was the key out of the.
I mean, the main concern with it, it's like financial space.
Yeah.
The number.
Yeah.
It's available.
We just wait, Drew. So you think there, ignore that. I think the bad idea here is a good idea. Well, the idea here is not, it's bad.
It isn't. What? Every experiment. One of the experiments, the Bendo experiment, I think that as what.
That's right. Right. One of the main reasons why Herbert is not working in time.
But. Hello, never the voice, but like.
I was comment on the next slide.
Yeah, that battery, that battery.
Here.
Fine. That's a lithium ion.
That's-
Yeah. But
Well, I don't. So you said it's 12,000 milliamp hours, presumably to power everything for clients, which is cool. If that one battery doesn't work, nothing works. So it is a very like centralized single point of failure. Which is
redundant batteries, like not as actually.
not about battery groups.
Yeah, but like if one.
If you need to find a different battery, if the makes a different voltage than the logic.
Yeah. Also, you should look into like energy to be math does like. Because it weighs half pound, which is kind of a lot.
Yeah.
So if you use like the compliant lithium-ion batteries, which you gotta active anyway, you might find that you can make it lighter even if you have separate batteries for separate.
Anyway, the big thing is only cylindrical lithium ion batteries are allowed that. is-
Cylindrical metal case.
Yes, yeah, that
They're pretty.
is not, that is definitely not that. If you want something that's rectangular, you probably gonna have to use lithium ion batteries. Like if you, like, if you wanted it, like, that's what you think. Cause like, those are, they usually have the JSP package built in, whereas with the cylindrical ones, often we have to like. It's got to don't connect with on, and be a pain, I think. It would still become a bad possibility.
Yes.
I have a lot of comments that are mixed of mine and Garrett's. The first one is, needs to be 5 volts, hard to find. Why can't you just use a buck? We've been different voltage, it's hard to find the rectifier.
I think.
Yeah.
Yeah.
That's what we're gonna, I think.
Okay, I think both are higher than.
Yeah, I don't
Anyway, second of all, I don't think it needs to be 5 volt. In fact, I think it has to be between 7 and 12 volts. Dialed into it. So your IO pins, will be our operating at 5 volts, but your input voltage needs to be between 7 and 12 for us to. So then, yeah, take the battery. So I think strand gauge on this does require.
Yeah, you,
5 volts. Yes, we know we will provide 5 volts, then you provide our VR.
You can also get that are adjustable output. So if you needed 5 volts for everything, that capacity wouldn't be helpful. But for something like this, you want to get that. I think the ones we already thought.
there should be no issue with using both of them.
Yeah. And there it says, battery just look like 2, okay, wait, that's what exactly. Never mind, yeah.
And affected by AC and DC. It's a boost converter and buck converter, DC and DC. Yeah,
Or step up, step down.
yeah.
Questions or the modifications? Oh, that's actually from a friend of my team who has like a computer.
We need one of them.
Oh, yeah.
Is that USB to your board?
I think so. Yeah, I can just give you like a slack.
No, if it's not ours, it doesn't matter. I'm just buy one and not. They're like $1 one, buy it and then it's the same as it's.
119.
119 or fire. Anybody 118 or we're good?
I think we mentioned the on about the thermal cycle, the market is held together with the box. That wasn't easily put in the pocket.
Yeah.
Why not do it on unbreakable clamp so you can edit the wire right
Yeah, all that.
That means I mean, like,
Just move the wall or something.
yeah, that's why I didn't like that.
Yeah, like just.
You can glue on things that you can dip into. That's the thing. It's up to you to decide if that's cool. Like, if you're saying, oh, the tiniest bit of movement corrupts our data, don't do that, glue it the entire way. But if you don't need that, it would probably be easier to do that. Yeah, so I would also say.
Hot glue will absolutely no.
Yeah, probably just get hot glue that is higher temperature,
We
right?
have hot glue guns that can melt.
You just. We get what?
Yeah, but my point is like, we have a box thing.
That's gonna be launch of ABI.
I will point out,
Is very permanent, you wanna do that.
I know nothing good ever starts with on air brakes test rocket. I'm gonna say this. On air brakes test rocket, we did talk to a bunch of stuff, and that was one of the few choices that survived getting the ground.
Like, so, I'm getting, I'm like, what? Like, you're not like, you're not like. Yeah.
I mean, was it special hot glue? Nope, we just used regular.
Well, look, they did not between the death and that's not very.
Hot glue, well, I mean, you can't, different types of hot glue, melt at different types. Yeah, one that doesn't melt, no, that's true.
That's not.
Yeah.
High temp power. Something.
Five down. Max five, 122. Four. Might want to just constantly report and save from loss, you can have data. Oh, yeah, yeah, you might want to be constantly reporting but not logging, but you might want to have your like thing reporting but not like saving the data on that for launch and only starts like saving your data at launch. You have data like at like a little before the moment. Because everything is still getting powered.
Yeah, no, we're definitely gonna do that. I don't know, it's just probably, but.
That looks like a mighty detailed design to me.
That's also not right because they're not using the objects.
Yeah.
It could have been five words, but now it's five.
This code of development doesn't.
I think your conceptual design is just that text on this side.
It's true.
And your detail, like what, like how the detail designer. How the
Yeah. But this is how I don't think you. I didn't.
Okay, conceptually, we need this photo business plan.
Yes, so like not using the lab jet is a conceptual something.
And then, but then
We see
that's
that.
an example, you can, why would you put lab jacks and. Oh, good, we don't have.
And go next.
Alright, next slide.
Yeah,
So, I think they're.
Yeah.
Good job, Jonathan. Literally, no one's ever done this before.
Yeah.
Alex, you got that right.
Sure.
Okay.
Can I just ask off the bat, what are you feeling percentage wise for functional theory at the end of this year? If that's only real confident.
I mean, we're on track for 100%.
Okay, this would be really feel. Is this
The
any?
only thing with this one is GPS.
Guys. So, you guys right here.
Yeah.
128.
Oh, yeah. I have to, that's all the, yeah. Like, this is a cool update, like, this isn't really relevant, but that's like, it's like a serious progress. Yeah.
Like, I mean, but like, what do we do for their step?
Yeah, that's what I would say, like, this technically, in my head, it's stuff. All. Except for selecting components, so like, I think you're done, I don't say you slow them out, like on the slider, you pass out the 80 on. It doesn't like fit in ODR, but it's useful to have that. Yes, that.
Garrett wants to know, now that you figured the voltage regulator, what if? Yeah. What, 5? And this is a comment, not a question or anything like that, thank you for adding a magnetometer, and I appreciate the flash increase as well.
Yeah, I agree. In terms of, 31, this one?
What is long distances?
Okay. Can't believe with that stuff. Really like, I don't know a good place to test it. We're not gonna be going like thousands of acres,
So no, we're not doing that in the farm.
no,
Okay,
it's all on.
okay. B, what's a voltage?
I'm not over.
Is it Serena?
Yes.
Okay. Because I would like to know if you're using it with sensor or air states. It's unsensed now that you have a magnetometer. That's what you do. Yeah.
That's the reason for the.
Yeah. My next thing is 133.
132. Why not using Blue Raven and IntelliGPS? They're good, we have both.
Oh, we have them?
Yes, we have like. I don't know. Let's don't really.
Yeah.
It's like 2 months to do releasing. It's like lots of updates.
Blue Ravens are good. Like more of them.
Yeah. But I do think the odds a little bit. I know, it's like some
I personally have not had those issues.
I think like, one thing that they are, I would say generally been left alive.
And if the Bluetooth doesn't work, it's a Raven forward.
No, you can't buy.
Big ass.
I thought I could tell you guys that, but. Yeah, I could have done wrong, but I said, it's either the end.
We should at least look into it.
Yeah, no, I.
And then. Okay. This is the thing, why are we not using LGPS?
Because everything for the past year, you install GPS and the GPS is falling on the board.
That happened through the Featherweight too? I think.
It's about impact in the GPS.
That. Yeah. It's like for the team, like for one. The way that TeleGPS works better with how we do recovery.
The antenna is longer, so you have to account for that, and it is less stiff, so you need to account for that. Both of which are very possible, so long as your EJ is not. We also just do forever.
And then you're saying, let's say, the the element are all different things. And I know it's your refrigerator on what's. Okay, you have to make sure that like a fan like beyond.
Anything else?
You talk about batteries here, but.
We don't have any. It's. Probably just gonna be the same thing we have down every single year.
Okay.
That's the deal.
Okay, sure.
133.
You're covered.
So you kind of into this, but why are we using the split age?
I don't know, I wanted to talk to somebody about that.
Okay, so we have never used it successfully. It is better than the thumb two. Have we used the thumb two successfully? Okay, so we have experience with split age. Granted, it is experience in which we learn we can snap properly. But it is never used in the experience. I think you're experience on this T period.
I've never done that.
Yes, I would try this with H first because it is just objectively a better camera.
Yeah, I like, it's like available frame rate center.
Yeah. And then like you where that probably a problem unless they like one cam you yeah. Try not to kill them like
A one cam booty.
you're to know is what
Your comment about probably much less than NVD, I really don't think that has a average picture. It's probably recording in 4K and down there.
I don't think so, because it talks about heat dissipation, it's like if you're running it at 4K, you get like 30 seconds or something. But if you're running it less, then you don't have to worry.
BPS, people.
Yeah, just put it. You can use cameras normally, we're not gonna start cutting them open.
Yeah.
We should use the GoPro and cutting them. I mean, if we can find a GoPro, that like without popping normal version, like we can cut. Like, I would rather us use the GoPro than one cam.
I didn't remember about the GoPro, what's up with like the hundreds of GoPro casings in the camera drawer, but no GoPro?
I don't know, we only want to GoPro to them.
Yeah, I think we had like a Europe thing. No, I think it's like Europe. But it's very.
Point is, if we could, if like other camera options.
Yeah.
The only thing I have in what is you
Yeah.
Actually, before we talked about Searing. 440 volts, pretty please.
440 volts?
Yeah.
bolts.
Oh, bolts.
Oh, bolts.
Everything else, except for the LED, we talked about that. Everything else uses 440. The less screws, the less XT cap.
Yeah, I was part of the payload thing, that was horrible. So
Yeah.
I-
If you could make Searing 440 volts.
And then the next thing on technically, I guess 134. Do you have the compliance for S2R1 or
It should be all the same, it's really
sure? And also is
it'll be worth that.
did we have not?
It's gonna be good done, and we're on.
I'm counting and you.
You didn't want to have time by Wednesday?
Great.
What time is it?
At the end of the day, the business day, and to the 11:59. So. Yeah.
Yeah, I don't, it's no,
But I mean, like, if you are done sometime this week, let me know and I'll see if I can.
okay. Yeah, I want to review what Serena was gonna have for the birthday. Yeah, I thought that would be neat. I guess I could be there something like that.
Yeah, do what you will do, the message be clear. That is everything, both I and your, I have anything, does anyone have anything else? Great, good.
Yeah.
Thank you all for being here and
Thank you all so much for cleaning up.
answering the 9:30
And
done.
and an 8 eval.
Over yet. Yeah, that, I had work to say and my brain was
Not
not,
only did we do one, but it also did stuff very cool.
yeah.
Yeah.
Great job to the lead, because they're the ones who actually put in all this work. I just talk at them an hour a week. I'll see you all for PDR basically. But, and like. You want. What do you think? A little bit every time. Oh, Professor, we are.
Professor?
Yeah.
I'll be great. I haven't said it like that. I need to, I don't. Yeah. There's another thing that needs to be on credit. 5 minutes. Well, I can bring it. It's that's some, I think. Probably wasn't saying that. That would be
One day where you have to go. Fluid. I think fluid. You can carry your house. Let's keep it right. Also, like.
Okay, stop recording.